back in 2022. But so far today, on our first launch attempt, we're really enjoying some really solid countdown work, some solid operations by the launch team so far. And to quote our friend Lucas, who created Earthrise, we all really like that. We'll send it back to the host desk.
Thanks so much, Daryl. Yes, we really like that. And we really like Rise and Lucas. So thank you for that. That was really cute. Okay, so again, here we are in the big box here. We have our full view of the rocket looking glorious on there with, again, some clouds, but still weather is good for launch today. And then we have the closeout team continuing to do work in the White Room. We got confirmation that they have successfully completed pressurizing the counterbalance pressurization. Basically, as Daryl explained it before, the side hatch for the crew module is very heavy. So in order to open it, there needs to be pressure applied to it, and that's what we just completed, right?
Right, that's exactly it. So the CBA, that counterbalance assembly that we're talking about, has to be pressurized. It's a pneumatic system to help. So in the case of an egress, Christina's the one that has to open that hatch. So once she gets it unlatched and unlocked, then that pneumatic system will help move the hatch. It weighs a lot, and so the average human cannot open that hatch by themselves. And so that's why we want to make sure that the system is pressurized, that it's not going to leak, and that it is ready to go in case they need to open the hatch.
So that is complete, and now what is happening are the seal leak checks. So that is in progress. Again, 2 seals go through the entirety of the hatch, and we will take the seals to pressure, hold it for about a minute, and just make sure that it is holding pressure. Again, we want to make sure that the crew has a safe, pressurized environment in any sort of situation while they're in Orion.
Yep, that's right. So we're going to take a look at it. We're going to take a look at the starting pressure, and then after a certain amount of time, we'll take a look at the ending pressure, and then there are certain tolerances that we will accept for flight.
2 hours, 37 minutes and counting from the opening of our 2-hour launch window today at 6:24 p.m. Eastern Time. After liftoff, it takes less than 10 minutes to reach Earth's orbit. Let's learn more about today's Ascent profile with Gary in Mission Control.
Hey, Megan. We are monitoring here in Mission Control Houston. Flight controllers are looking at data from integrity in the Space Launch System during the countdown. We're looking at some of the events happening in the White Room now and just making sure that all criteria is met to commit to launch and Ascent today. It's the team you see in this room that would be looking after Ascent, which is a very dynamic phase of flight. And after solid rocket booster ignition of the Space Launch System, it's this team that takes over control of the mission. There are voices you'll hear upon ascent, calls being relayed between Stan Love, the Capcom you see here in this shot in Mission Control Houston, that's the voice from this room, and the Artemis II crew on a communications channel aptly named Orion to Earth. Here are the calls you may hear during this part of the mission. Capcom Stan Love, his first call after responding to the crew's successful roll pitch maneuver at 30 seconds is AMT high. This notes that should we lose just one of the main engines, an alternate mission in low Earth orbit can still be achieved. At 1 minute 25 seconds, you'll hear max Q on PDL. This notes that reaching the moment of maximum dynamic pressure on the spacecraft. This event happens to be in line with a communication switch to another ground station, the Ponce de Leon Inlet Tracking Annex, located about 35 miles north of Kennedy. At 2 minutes 45 seconds, you'll hear SM primed, upper stage RCS ready. This means that the European Service Module propulsion system that's prepared for the next phase of aborts after the launch abort system jettisons, and the reaction control thrusters on the inner rim cryogenic propulsion stage that enable pointing and maneuvering are ready. At 3 minutes 50 seconds, you'll hear voice check on TDRS at the Kármán line. At this point, the launch abort system has jettisoned and revealed the Orion capsule underneath. This check verifies that the now exposed Orion antennas have a good signal. the tracking and data relay tracking and data relay satellites, which is part of the geosynchronous satellite network and the same assets that are used aboard the International Space Station. This communication switch happens to be at the Kármán line, a widely recognized boundary about 62 miles, statute miles, or 100 kilometers above the Earth's surface, where the air is too thin for conventional aircraft to fly and marks the point where our astronauts leave Earth and enter space. At 5 minutes 16 seconds, you'll hear the call 3-engine press. This notes that if one of the 4 main engines on the SLS core stage were to fail, 3 engines can carry the crew to a nominal main engine cutoff and proceed with the expected mission timeline. This is an important call that gives more assurance of continuing today's moon mission. At 7 minutes, you'll hear expect nominal shutdown. You'll hear this call should the main engine performance be as expected up to this point. Shutdown plans can vary and may impact G-forces experienced by the crew or future burn plans, but a nominal shutdown is more indicative of continuing the mission on the expected timeline. At 7 minutes 30 seconds, you'll hear AOA open. This notes crossing into a new abort profile. At this point, an abort would use Orion engines to escape the core stage, and the altitude and velocity are enough to make it 1 lap around the Earth and aim for a splashdown in the Pacific Ocean instead of the Atlantic. And then, of course, shortly after 8 minutes, you'll hear nominal MECO. You won't hear MECO right away. Teams here wait until the core stage has separated and the trajectory is confirmed as expected before that call to the crew. Now, this ascent profile is approximate, as there may be calls that move a few seconds depending on the trajectory, and of course these are the calls and times for a nominal trajectory. Teams in this room have been training extensively to prepare for any and all scenarios, and they are confident and ready to take this crew into space today. In today's pre-brief, the flight director, Judd Freeling, expressed his confidence to the team, citing the hundreds of simulations to prepare for this very moment. These are the calls you'll hear during Ascent less than 3 hours from now. But now we'll turn our attention to the countdown to launch and send it back to you, Megan, at the Space Coast.
Thanks so much, Gary. Now, one of today's 4 astronauts, of course, Canadian Space Agency astronaut Jeremy Hansen. Let's go now to Jasmine with her next guest.
Thanks so much, Megan. Yeah, we're joining you live now from the Operations Support Building here at Kennedy, where crowds are starting to gather, and we're honored to have Lisa Campbell of the Canadian Space Agency joining us. Lisa, Jeremy Hansen is about to make history as the first Canadian to venture to the moon. What does that milestone mean for your agency?
Thanks so much, Jasmine. It's wonderful to be here. It's such a special moment, both for our astronaut colleague, Jeremy Hansen, but also for Canada. We're here because of decades of public investment in space robotics, in space collaboration, and so for our country, we're very proud. He's so ready. He's been waiting for this his whole life, preparing, training, and he's a wonderful example of Canada.
Yeah, and that's a perfect way to capture Jeremy. He really has been prepping for this his whole life. This will be his first space flight. So what has it been like watching him become part of this Artemis II crew?
Well, as I mentioned to you, I've known Jeremy since 2020, and he's a colonel, a fighter pilot, a father, and he really is a very dedicated, passionate human being. So both for him to realize this goal of being an astronaut and flying, he also is hopeful that witnessing that will raise awareness about the value of a space program, of the benefits here on Earth, of exploring the universe and our place in it.
Wow, that's beautifully said. And really, this international collaboration has been going on for quite some time now. We've worked together in low Earth orbit and now going into deep space together. So why is it so important that we have these international partnerships?
It makes us stronger. We can go faster and further together. Canada is one of the original signatories of the Artemis Accords, and Canada and the United States have been partnered for more than 60 years in space.
Wow, that is phenomenal, Lisa. And this really is a team effort in many ways. We also have Jenny Gibbons.
Yes.
She'll be listening in on Capcom. What is her role going to be like?
So Dr. Jenny Gibbons has been training all along as the Canadian backup with the prime crew. Last night, she was in the Orion capsule checking out all of the communications, making sure all of the systems test out and work perfectly. And then she will be among the first Lunar Capcom, helping the astronauts navigate during their mission.
Wow, Lisa, that is so exciting. Any final words for the nation of Canada before today's mission?
Just, we are so proud, so excited, and we can't wait to welcome Jeremy home.
Oh, fantastic. Lisa Campbell, thank you so much for being here today.
Thank you, Jasmine.
Of course. And with that, let's get back to NASA's Megan Cruz.
And right now,
Orion Earth 1. Go ahead. Ma'am, CBA press has been completed. Did you see any drop in pressure?
And MS1, we saw just a little bit. It is just over 2,600 now.
Copy. Thank you, ma'am.
Again, a call out to mission specialist Christina Cook. Again, it was her responsibility to monitor the pressure on the counterbalance system that will help open the side hatch. And she did report a drop in pressure, but it seems like it's within nominal limits.
Right. They might have had a small drop, but we have a starting pressure and an ending pressure, and as long as the difference isn't too high, then we will take that. And the engineers know exactly what they're looking at for in terms of that delta pressure.
And so again, that milestone on the checklist of things that have to happen before they launch today, that is complete. The crew, again, still inside comfortably as the closeout crew team work to close the side hatch. Again, a separate seal leak check, followed by a full cabin leak check, and then they will close the last abort system hatch.
Lots to do still in the White Room and marching down the countdown timeline well.
And so Bill, again, number 3 there, he is holding a silver flex hose. That hose is what will be connected to Orion in order to do that cabin leak check. So again, it does seem like we continue to march down through the milestones in this countdown. Hopefully lifting off today within our 2-hour launch window that opens at 6:24 p.m. Now, right now, people inside the Kennedy Space Center Visitors Complex are learning about this mission. There are great exhibits there about the rocket and Orion, and of course, our Megan Carter with the moonboard.
All right, Megan and Nicole, yeah, you mentioned that checklist before launch. That checklist is going to continue during the mission, as well as there are several vital objectives that we are hoping to accomplish with this mission. So we've talked about the rocket. We've talked a little bit about Orion. Obviously, during Artemis I, we had that test flight, and there were no humans on board. That is our one big difference for this one, and we are going to have that crew this time. So what are they going to be up to during this mission? Let me tell you just a little bit. Now, for Artemis I, like I mentioned, we were really focused on the SLS, making sure it had the power and capabilities that we needed. We were also checking out the Orion spacecraft in deep space environments, making sure that it was good to go. Now for Artemis II, we are going to be taking the testing for Orion to the next level by adding that human component. So those test objectives are going to start even before launch. Like you mentioned, they are out there making their way through that checklist. But these objectives are going to start now, and that includes safety. So one really great example of safety is going to be something called the egress baskets. They're out there in the spacecraft, obviously, and should a situation happen to come up, they are going to have something called the egress baskets they can get in, and those are going to zip line them essentially down to the ground within seconds to safety. Another great example of those safety procedures are going to be the LAS, or the launch abort system that I mentioned earlier. Just a reminder, that's the one that can pull the crew and capsule away from any danger within a few minutes of into the launch. Now, those are just a couple quick examples, but our recovery teams have been training extensively, quite a lot, to make sure that they are ready and prepared for any challenging situation that could possibly arise. All right. Several other objectives that we are going to be looking at are also going to be communication checkouts. That is going to be vital. I know we talked a little bit earlier about all the maneuvering that they're going to be able to do, but we want to make sure that they have full communication ability from space to ground so that we can fully support them here. We are also going to be checking out those life support systems. Obviously, we've talked a lot about the service module and what it is going to do for the crew, but we want to make sure that those life support systems are fully functioning, obviously, before we send them farther into deep space. That's going to be critical for them. So on top of being able to maneuver the spacecraft and check everything out, we are also going to be making sure that everything is fully functioning.
So as you can see, big part of this mission is to make sure that the spacecraft, the hardware, and all the operations are working and that the data is going to make sense. And speaking of recovery, we are also going to have the opportunity at splashdown to recover that launch or that flight data, and we're going to be able to take that back, analyze it, and make sure there are if there are any enhancements we need or changes we need to make before our next missions, we'll be able to do so. So lots to do. They're going to stay very busy, obviously. And with that, I will turn it back over to you, Megan.
2 hours, 25 minutes and counting, and the crowd, check it out, continues to grow at our Banana Creek viewing location. They will have a great view of launch, and we will go back now to Leah Martin, who's standing with her next guests.
Hey, Megan. Yeah, we're surrounded by thousands of people, some here local from the Space Coast, but we actually have quite a few people who have traveled a pretty far distance to be with us today. I'm actually joined here by a group from the International Space Station Ambassadors Program who have come from all over the globe. Saku, you're here from Japan. You've come, Val, from Mexico, and then we have brother and sister Cosma and Jesko here who are visiting from Germany. You actually told me that you participated in the NASA Rover Challenge in Huntsville. How was that experience, and how is it kind of participating there in Alabama and then being here today?
So it is an amazing experience because you meet so many young people with visions, with dreams, with ideas, which inspire you and motivate you. And it's even better to be here now to see the SLS launch because we are going back.
Do that. Tell me a little bit about that.
It's actually I applied for the Japanese Aerospace Agency, the astronaut selection like 2 years ago, and then I didn't make it all the way, but I'm still working on it, and hopefully I can be at the launch pad sometime, and then I hope to go back to the moon and Mars, and yeah, I'm working on it.
Absolutely incredible. And Val, you're from Mexico. We were talking a little bit about women in space. This is a team who, is predominantly made up of women. What is it like knowing that Christina is on that rocket right now, about to be the first woman to travel around the moon?
I think that's such an amazing news. It's just so inspiring that we are taking the first Black person and also the first woman to the moon. It's just the first step in humanity and a big step in equality as well.
Megan, a lot of excitement here, not just in Florida, but from around the globe, and we're keeping our eye on that rocket, and we're ready to see it lift off.
Thanks, Leah. Yeah, a lot of excitement, but also a lot of inspiration. Again, this is part of our big reason why.
0.6.
क्या हाल चाल है? हाँ, ग्रेट डे भाई. अपन हिस्ट्री बनते हुए देखने वाले हैं. वी आर गोइंग बैक टू द मून. और जब लास्ट टाइम अमेरिका चांद पर गया था तो ये माना गया था कि वो VFX है. तो भैया अब तो डीप फेक वीडियोस बहुत अच्छे से बनते हैं, तो अब इसके लिए क्या बोला जाएगा. तो दोस्तों, थोड़ी सी अपडेट मेरे साइड से ये है कि थोड़ा सा मैं कनेक्टेड नहीं रहा हूँ इन दिनों. कुछ वीडियोस मेरे कम हुए, राइट. हाँ, अभी तो बहुत टाइम है. थोड़ी बातें करेंगे अपन बातें करेंगे. 4 बजे के आसपास है ना. सो वी विल टॉक अबाउट फ्यू थिंग्स. तो मैं अभी डायरेक्ट हॉस्पिटल से ही आ रहा हूँ, और मैं 2 रात हो गई नहीं मुझे सोए हुए, एंड यही कपड़े पहन के घूम रहा हूँ 2 दिन से. बट दिन अब मैं जगा हुआ था. जस्ट नाउ मैं आधी घंटा पहले हॉस्पिटल से आया था. तो आई थॉट कि मैंने स्ट्रीम पहले नहीं बना रखी थी, बट आई थॉट दैट फाइन, चलो कर लेते हैं, भी जगह हुए हैं तो. करेंगे कभी बातें, ये सारी बातें भी करेंगे आपसे बैठ के. थोड़ा सा रूटीन सही होगा तो. लॉट मेनी थिंग्स आर हैपनिंग. ऐसा है, काफी कुछ हो रहा है. फाइन. नहीं, मैं तो ठीक हूँ. मैम की तबीयत थोड़ी ज्यादा खराब हो गई. मैम की तबीयत ओके, सो वही देखो, ऐसा अभी तो 2 घंटा 20 मिनट बचे हुए हैं, राइट। अब एक चीज देखो यार जो ज्यादा इंटरेस्टिंग है, यहाँ पर 2 घंटा 20 मिनट भी लॉन्च में बचे हुए हैं। आई थिंक ये स्ट्रीम काफी लंबे समय से चल रही है ऑलरेडी। लुक एट द वाइड कवरेज, एंड ये देखो इंटरनेशनल स्पेस स्टेशन है, एंड दे आर क्लियरली शोइंग कि ग्रेविटी का भी लेना देना नहीं है। उन्हें देखो नीचे पैर उनने अटका रखे हैं। अब यू कांट टेल कि कौन सीधा है कौन उल्टा, बिकॉज ग्रेविटी माइक्रो ग्रेविटी फर्क ही नहीं पड़ता। बट देन ये जैसे काफी सवाल काफी जगह पे डिस्कशन हुआ है कि ऐसा क्या हुआ कि आप 60 साल पहले जाके आए एंड देन फिर 60 साल बाद आप फिर से जा रहे हैं, एंड देन यू आर स्टिल फेसिंग चैलेंजेस। देखो कुछ ग्लिम्पसेस वी आर सीइंग ऑफ द काइंड ऑफ ट्रेनिंग दैट हैपेंस फॉर द माइक्रोग्रेविटी, एंड तो ऐसा हुआ क्या? तो देखो दोस्तों, ये है कि जब 60 साल पहले हम चांद पे गई थी ना ह्यूमैनिटी, वो पर्पस अलग था। वो एक रेस, वाओ व्हाट अ ब्यूटीफुल शॉट, हाँ वहीं तो जाना है इस रॉकेट को, राइट। व्हाट अ ब्यूटीफुल कैप्चर दैट वाज, है ना। हाँ नहीं, एक्चुअली इनका कवरेज तो इनॉर्मस हार्ड वर्किंग काइंड ऑफ स्टफ इज, and then they spend a lot, इनका फोकस होता है कि आउटरीच प्रॉपर होनी चाहिए। देखो यहाँ पे ये जहां से ये स्ट्रीम आ रही है, जहां पर ये दो नासा के ये जो 2 लोग बात कर रहे हैं, पीछे यू कैन सी खूब सारे लोग। ओके, लेट्स लिसन टू दिस।
On board Orion, but along with that, we're doing a lot of great science.
One of the exciting things about the Artemis missions to the moon is that science is actually a fundamental pillar of why we explore, why we're going, what we're doing in Artemis.
I think it's incredibly exciting that not only are we testing the vehicle, but we're testing science on board. Science where the astronauts are conducting experiments, science riding along with the astronauts. We have astronauts looking outside the window and really observing the lunar surface.
It will help us understand the deep space environment. It will help us understand how that environment affects our astronauts, our systems, and life in general.
So deep space is a challenge for us because you have to leave Earth's protective magnetic field. Here in low Earth orbit, the crew members are protected from some of the harmful radiation. Going to the moon, they'll no longer be protected, so they'll have a higher radiation exposure.
Much like Artemis I, we have so many radiation sensors and detectors that are inside the capsule so that we can fully understand and appreciate the radiation environment for protecting our astronauts. In my hand here, I'm holding a tissue chip model. This is the exact design that's going to be flying alongside the astronauts. We'll be collecting samples from each of the crew members, and we can make these organ chips out of the astronauts themselves. So every crew member will have their own avatar on board, and then upon return we can evaluate that deep space radiation environment and what that compares to the astronaut themselves. Not only are they going to help change the course of medicine for the astronauts, but revolutionizing that on Earth as well.
We're looking at sleep, we're looking at team dynamics, we're looking at how you interact with the environment. We're also looking at the immune system. So what are the biomarkers? We're using saliva as a method to study hormones and different things in your body that may change during a mission like this. And then finally, how do we function after microgravity, being close to the moon, then returning to Earth?
Which will ultimately help us achieve our goal of getting humans to Mars.
And then on top of that, we have an opportunity to look at the moon from deep space on the far side for the first time in over 50 years.
Having human eyeballs and brains back around the moon is going to unlock a new generation of lunar science discovery. The human eyeball is capable of taking in so much data in just a split second. They'll be able to tackle impact history, volcanic history. They'll be able to look at how the albedo, or kind of the shade and hue of the moon and the color of the moon, can tell us something about how that terrain evolved over time. We're integrating science in ways that have never been integrated into human exploration before. We have a front room mission control flight controller position called the Science Officer. We have a brand new science back room where it's basically our brain trust of lunar scientists and geologists supporting the crews of the future. And Artemis II will allow us to really test how this works so that future missions are really set up for success.
We'll also be deploying some CubeSats. They're small shoebox.
Okay, I can see बच्चों के कुछ questions आ रही हैं. So let's start discussing that also. तो बोल रहे हैं if they already touched moon in 1969, then why they are not trying to do it again? Why only rotation around the moon up to 10 days? See, the thing is, तब हम चांद के इक्वेटोरियल प्लेन में लैंड कर रहे थे जो अपोलो मिशन था. अभी लूनर पोलर रीजन इज द टारगेट लैंडिंग साइट एंड बिफोर डूइंग दैट दे वांट टू, जैसे बता रहे थे, दे वांट टू चेक कि रेडिएशंस का क्या इफेक्ट रहता है, माइक्रो ग्रेविटी का क्या इफेक्ट रहता है. तो दैट्स व्हाट दे आर ट्राइंग टू डू. दे आर ट्राइंग टू डू मोर साइंस आउट ऑफ दिस. सी, एक तो थ्रिल पार्ट होता है, आप चांद पे उतरने वाले हैं. एक थ्रिल पार्ट के अलावा साइंस पार्ट होता है. तो अभी इस मिशन का जो पर्पस है उसका ये, क्योंकि इसी लैंडिंग के अपने खुद के कुछ चैलेंजेस हैं. यू हैव टू लैंड देयर एंड देन यू हैव टू अगेन लिफ्ट ऑफ फ्रॉम द मून एंड कम बैक. तो एक तरीके से आप ये मान लीजिए कि स्टेप बाय स्टेप नासा इज अप्रोचिंग दिस मिशन स्टेप बाय स्टेप. इवेंचुअली उनको चांद पे लैंड करना है. उन्हें पहले सिर्फ ओरायन भेजा, राइट, जो आर्टेमिस 1 था. अब ओरायन के साथ वो 4 एस्ट्रोनॉट्स को भेज रहे हैं. अभी लैंडिंग अटेम्प्ट नहीं होगा, दे विल गो अराउंड द मून. सो इन दैट प्रोसेस दे आर गोइंग टू टेस्ट सो मेनी सब सिस्टम्स, क्योंकि ओरायन तो वहां पे है ना, ओरायन में तो है. तो दे आर गोइंग टू टेस्ट सो मेनी सब सिस्टम्स एंड वो एक टेस्ट बेड हो गया. वहां पे उन्हें अपनी टेक्नोलॉजीज को टेस्ट कर लिया, अपने सब सिस्टम्स को टेस्ट कर लिया. एंड देन व्हेन दे आर प्लानिंग टू लैंड ऑन द मून, तो वो उनके लिए एक रिहर्सल हो गई. तो ये तो आगे आंसर इसका कि जब पहले चांद पे उतरे हुए तो क्यों नहीं उतरे, क्योंकि अभी चैलेंजेस अलग हैं. क्योंकि अभी हम इक्वेटोरियल प्लेन में नहीं उतरने वाले, हम चांद पे जा रहे हैं और के पोलर रीजन में जा रहे हैं. चंद्रयान 3 जैसे गया था. ओके, व्हाई दे विल नॉट डू एनीथिंग फ्रॉम प्रीवियस 50 years डिस्पाइट दे हैव डन इट. ओके, देखो 50-60 साल पहले उन्होंने किया था, अब इतना टाइम क्यों लगा? यू कैन से कभी कभी इग्नोरेंस इज अ ब्लिस. तो उस वक्त जो टेक्नोलॉजी थी वो उस टाइम के हिसाब से वन ऑफ द बेस्ट थी. बट देन इवेंचुअली यू नो, जैसे जैसे टेक्नोलॉजी इंप्रूव होती है, जैसे जैसे टेक्नोलॉजी मैच्योर होती है, देन यू रियलाइज यार वी वर लकी. हाँ, हमने तो ABCDEF इतने सारे ऑप्शंस तो हमने इवैल्यूएट ही नहीं करे थे. एंड वी वर रियली लकी कि everything just worked perfectly fine. तो ये आपने बहुत बार सुना होगा कि आप जितना ज्यादा पढ़ते हैं तो आपको लगता है आपको उतना ही कम आता है. समझिए इस बात को, राइट? तो जैसे जैसे स्पेस एक्सप्लोरेशन का जो टेक्नोलॉजिकल ओवरव्यू बढ़ने लगा, ज्यादा से ज्यादा टेक्नोलॉजी के बारे में पता चलने लगा और सोफिस्टिकेटेड टेक्नोलॉजी समझ में आने लगी. टेक्नोलॉजी ने पूरी 1960s से लेके आज तक में टेक्नोलॉजी कंप्लीटली बदल चुकी है. कंप्लीट, ये तो आप भी जानते हैं. तो जितना ज्यादा फिर टेक्नोलॉजी के बारे में पता चला, then it was realized कि वी वर लकी कि उससे कुछ हुआ नहीं. लेकिन तब आइडिया नहीं था कि क्या क्या हो सकता है. लेकिन टेक्नोलॉजी इतनी मैच्योर हो गई है कि चैलेंजेस ज्यादा पता लगने लग गए हैं. और अपोलो मिशंस भी वेल थॉट आउट, वेल चार्टेड, वेल प्लान्ड आउट मिशंस थे. बट देन right now technology is so mature, there are so many possibilities. तो उसके साथ आप जब ये समझते हैं ना कि मैं इतना कुछ कर सकता हूं, तो आप ये भी वैल्यूएट करते हैं कि इतना कुछ गलत भी हो सकता है. तो वो एक पार्ट है. बजट इज वन ऑफ द थिंग. एंड बीच में फिर क्या है, कोविड वगैरह ने थोड़ा पुश कर दिया. मिशन तो बहुत पहले हो जाने थे, 2020-21 से सुन रहा हूं मैं, तो तब हो जाने चाहिए थे. आज तो 2026 में जा रहा है. तो डिले तो हुए हैं, ये बात तो सच है. तो लेकिन फिर भी मान के चलिए, देखिए 60 साल लगे हैं, राइट? ओके, ओके. तो एक बच्चे का क्वेश्चन है कि F1 इंजन जो उसमें RP1 यूज किया, लिक्विड ऑक्सीजन क्यों नहीं यूज किया? सी, लिक्विड ऑक्सीजन जो ऑक्सीडाइजर है उसको क्यों नहीं यूज किया? वो ऑक्सीडाइजर है ना, उसको यूज नहीं करते हैं, फ्यूल को यूज करा जाता है। फ्यूल को यूज करते, वो साइकिल होती है ना, फ्यूल साइकिल होती है ना। तो इंजन की डिजाइन की जो बेसिक क्या कहते हैं उसको, उसके पीछे का जो थॉट प्रोसेस होता है कि इंजन जब हम डिजाइन कर रहे हैं तो उसकी कुछ कैटेगरीज होती है। आई थिंक आई हैव डन मल्टीपल वीडियोस ऑन दैट, और काफी लाइव सेशंस में भी मैंने बात करी है। तो जो F1 इंजन है उसकी जो डिजाइन मेथोडोलॉजी, जिस तरीके से उस इंजन को डिजाइन किया गया है, उसमें फ्यूल इज रिस्पॉन्सिबल टू टेक आउट द हीट। तो दैट्स व्हाई इट इज बीइंग डन दैट वे। तो वो नोजल के थ्रू पतले पतले चैम्बर्स में फ्लो करता है और हीट को टेक आउट करता है, एंड ब्यूटिफुली दे डू दैट। और सिमिलरली जो, और ये सेमी क्रायो है ना एक तरीके से, लॉक्स RP1, अगर लॉक्स H2 होता तो वो क्रायो होता है ना। तो ये सेमी क्रायो इंजन है, एंड मतलब इनको लिक्विड इंजन ही कहा जाता है। जैसे अपना विकास है ना, उसको अपन लिक्विड इंजन कहते हैं, इसको भी लिक्विड इंजन कहा जाता है। दिस इज ऑल्सो लिक्विड इंजन। यस, लॉन्च जो है वो अपने हिसाब से 4 बजे के आसपास है। मैं सोचा थोड़ी सी बातें कर लेते हैं आप लोगों से। बड़ा साइट यार, क्या ब्यूटीफुल साइट है, देखो। हाँ, एक और बच्चे का था कि फॉल्कन क्यों नहीं यूज कर रहे। हम भी जाएंगे हम सी, वी ऑलरेडी नो राइट नाउ व्हाट्स हैपनिंग विद आवर स्पेस प्रोग्राम, काइंड ऑफ चैलेंजेस जो हमारे सामने आ रहे हैं, वो तो वी नो दैट, राइट। Right. Okay. Finding water on the moon, they decided to go to the moon again. नहीं, एक्चुअली क्या ना, सी ये कहीं ना कहीं मान के चलो ये स्पेस सुपरमेसी का ही गेम है। और एक लोहा था ना, अपना लोहा मनवाने की बात है। जब हमने चंद्रयान 3 से सॉफ्ट लैंडिंग करी चांद पे, अपने आप पूरे ग्लोबल उस पे प्लेटफॉर्म पे अपने आप ही डिस्कशन चालू हो गया। ओ वाओ, इसरो कैन डू दैट, इंडिया कैन डू दैट, इंडिया तो गजब हो गया, टेक्नोलॉजी में आगे बढ़ गया सब। जैसे ही 1-2 मिशन आगे पीछे गड़बड़ हुए तो फिर से क्वेश्चन मार्क आ गया। तो ओके, एक्सप्लोरेशन एक पार्ट है, इंक्विजिटिवनेस पार्ट है, ह्यूमन नेचर है जानने का, टटोलने का, क्या है वहां पे समझने का। एक एस्पेक्ट वो भी है कि वहां पे फ्यूल मिल जाएगा, हीलियम 3 मिल जाएगा, पानी है, पानी को तोड़ के हम ऑक्सीडाइजर ऑक्सीजन बना लेंगे, सस्टेन्ड स्टे ऑन द मून होगा, ज्यादा देर तक रुकेंगे वहां पे, लूनर डिपो बनेगा, लूनर स्पेस स्टेशन बनेगा जो चांद पे चारों तरफ घूमेगा, सारी चीजें हैं। बट ये सब करना क्यों है? इसको करने से होगा क्या? ओके फाइन, ह्यूमैनिटी का फायदा होगा बिल्कुल होगा, बट देन उससे बड़ी बात there has to be something also ना, कि इतना एडवांस्ड देश है, इतने चैलेंजिंग मिशन कर लेता है, टेक्नोलॉजी इतनी ज्यादा पावरफुल है, ये सवाल भी तो आता है। ये भी तो एक पहलू होता है, ये तो इतने भयंकर मिशन को कर लेते हैं। जब इसरो ने किया चंद्रयान 3, उसके बाद इसरो का माहौल बना, तो ये वो वाला पार्ट भी रहता है, आप इसको नजरअंदाज नहीं कर सकते। हाँ, अब सवाल आता है फॉल्कन हैवी की जगह हम ये क्यों कर रहे हैं SLS। एक्चुअली ये आर्टेमिस का जो प्रपोजल था, वो प्रपोजल बहुत पुराना है। हाँ, वो प्रपोजल मतलब फॉल्कन हैवी वगैरह के टाइम का नहीं है, पुराना प्रपोजल है, वो बहुत पहले से है कि आर्टेमिस करना है। फिर ठंडे बक्से में चला गया था, फिर इसको फिर से रिवाइव किया गया कि हाँ, वी आर गोइंग टू गो बैक टू द मून, हम फिर से चांद पे जाएंगे। और फिर एक पूरा डिटेल्ड प्लान बनता है। तो इसको ऐसे समझो, NGL भी बना रहा है ना इंडिया, और 2031-32 तक NGL भी बन जाएगा, है ना, उसकी फ्लाइट्स भी जाएगी। बट देन यू हैव सीन कि LMLV की बात होती है लूनर मिशंस के लिए, तो वो स्पेसिफिक टू लूनर मिशन है। ये SLS जो है, दिस इज स्पेसिफिक फॉर आर्टेमिस, ये इसके लिए डिजाइंड है SLS जो है, और ये नासा डिजाइंड है। जैसे फॉल्कन तो SpaceX का हो गया, ये नासा का है। SLS इज नासाज लॉन्च व्हीकल। अब आपको लग रहा होगा यार इसका मतलब क्या हो, समझ में नहीं आया, नासाज लॉन्च व्हीकल। तो दोस्तों सच्चाई ये कि इस वक्त अमेरिका के अंदर जो लॉन्च केडेंस है, उनकी जो लॉन्च होते हैं रॉकेट, जो मिशंस लॉन्च होते हैं, जो इतनी सब हम सुनते हैं अमेरिका तो इतने मिशन लॉन्च कर रहा है, इतने मिशन लॉन्च कर रहा है, वो प्राइवेट प्लेयर करते हैं। स्पेसएक्स इज अ प्राइवेट प्लेयर। फॉल्कन हैवी या फॉल्कन 9 जो है वो इलोन मस्क की प्राइवेट प्रॉपर्टी है, वो उसका है, एंड ही इज फ्लाइंग दोज लॉन्च व्हीकल्स। और अपनी स्टारलिंक सैटेलाइट ज्यादा भेजता है वो। मैक्सिमम मिशंस आर ऑफ स्टारलिंक, वो किसकी है? इलोन मस्क की। किस कौन भेजता है उनको? स्पेसएक्स के थ्रू लॉन्च होता है। किसका? वो भी इलोन मस्क का। फॉल्कन 9 इलोन मस्क का है। तो ये कंप्लीटली प्राइवेट एंडेवर्स हैं स्पेस के अंदर, बट अमेरिका से सबसे ज्यादा हो रहे हैं। ठीक है, दूसरा रॉकेट लैब है जो, वो भी प्राइवेट एंटिटी है। हम जब बात करते हैं ईसा, यूरोपियन स्पेस एजेंसी का, यूरोपियन यूनियन की, तो उनके जो मोस्ट प्रोमिनेंट लॉन्च व्हीकल है वो एरियन स्पेस के हैं, जो सेमी पब्लिक प्राइवेट वो है, कॉम्पोजिशन है उनका। चाइना की हम बात करते हैं तो चाइना की जो स्पेस एक्सप्लोरेशन एजेंसी है उनके ज्यादा लॉन्च होते हैं, बट देन अब उनका प्राइवेट सेक्टर भी लॉन्च करने लग गया है, वो भी एक स्पेस को गेन कर रहा है। जापान की बात करें तो ज्यादातर से जाक्सा के लॉन्च होते हैं। इंडिया की बात करें तो इंडिया से इसरो के अलावा कौन सा लॉन्च हुआ है? सब ऑर्बिटल फ्लाइट ही बता दो कौन सी हुई है। स्टार्टअप्स तो आने बहुत बाकी हैं, अभी तो होगा, विक्रम का तो इस साल होगा जो फ्लाइट होगी। तो अब मैं फिर से उस बात पे आता हूँ, इसलिए नासा का है। जैसे LMLB जब बनेगा वो इसरो का होगा, अभी LBM-3 इसरो का है। तो अगर मैं इस लॉन्च व्हीकल की बात करूं, हाँ, तो ये इसरो का है, इंडिया का है, इसरो का है। लेकिन विक्रम जो होगा वो इंडिया का होगा, बट वो स्काई रूट का होगा। आई बात समझ में? तो SLS नासा का, ठीक है, सैटर्न नासा का था। लेकिन अब आपको ये बात भी जानकर बहुत ही हैरानी होगी कि नासा का है, नासा का था, बट देन स्टिल बहुत सारे कंपोनेंट्स इसके प्राइवेटली प्रोक्योर्ड होंगे। They might have been procured from the private players, प्राइवेट एंटिटी से उनको लिया होगा। और लुक एट दैट इलेबोरेट अरेंजमेंट्स। पीछे देखो लोगों के कैमरे लगे हुए हैं और दूर बैकग्राउंड में थोड़ा ब्लर्ड है, बट आउट ऑफ फोकस है, बट यू कैन सी द लॉन्च पैड। तो लिटरली दीज गाइस सेलिब्रेट, ये सेलिब्रेट करते हैं अपने लॉन्चेस को। दे सिंपली सेलिब्रेट देयर लॉन्चेस। गजब, बहुत इंटरेस्टिंग। सी एक्चुअली अपने इंडिया के साथ थोड़ा हुआ ये कि थोड़ा PSLV ने अपने अच्छे खासे प्लान, अच्छे खासे ट्रैक को डिस्टर्ब कर दिया। थोड़ा PSLV के जो फेलियर हुए ना, उनमें थोड़ा सा NBS-02 का GSLV का जो फायरवॉल था, जो ऑक्सीडाइजर ऑफ फ्यूल लाइन वाला जो इश्यू आया कि वो कनेक्टर जो था उसके चलते फेलियर हो गया, वो तो दूसरी चीज है। लेकिन आपकी थर्ड स्टेज ही मॉल फंक्शन कर जाए, आपकी सैटेलाइट ऑर्बिट तक न पहुंचे, तो वो बड़ा कंसर्न है, वो भी PSLV के केस में। तो उसने अपने स्पेस प्रोग्राम को थोड़ा सा ऑफ ट्रैक कर दिया है। क्यों? क्योंकि बैक टू बैक अगर इतने फेलियर होते हैं तो ये तो आप अगर आप इसको वैसे देखिए ना, कमर्शियल मार्केट है, स्टीव जॉब्स हैं, और स्टीव जॉब्स की सबसे खास बात क्या थी? जब उनने एप्पल के आईपॉड, आईपैड, मैकबुक, आईफोन, इनको जब लॉन्च किया, सो दैट द मार्केटिंग स्टाइल, द प्रेजेंस, द ओरा, राइट? अब मान लो वो बता रहे हैं मैक ओएस के बारे में, हाँ, स्टीव जॉब्स, वो हैंग कर जाए, वो बोल रहे हैं इट कांट हैंग, कुछ भी कर लो वो हैंग कर जाए। वो मैकबुक एयर की बात बता रहे हैं एंड मैकबुक एयर की बैटरी फट जाए। लॉन्च में बताया जा रहा है दुनिया को, देखो मैकबुक एयर है, इतना जबरदस्त हार्डवेयर है, पीस ऑफ ब्यूटीफुल पीस ऑफ हार्डवेयर, और बूम, राइट? तो इसरो अपने आप को प्रोजेक्ट कर रहा है कि हम हमारे मिशन तो लॉन्च कर ही रहे हैं, हमारा एक बूमिंग स्टार्टअप सेक्टर है, एंड अपार्ट फ्रॉम दैट हम भी कमर्शियल ऑपरेशंस चालू कर रहे हैं। वी आर रेडी फॉर कमर्शियल कोलैबोरेशंस। आप आइए, हम आपकी सैटेलाइट लॉन्च करते हैं। PSLV में क्या हुआ? इतने सारे स्टार्टअप्स की सैटेलाइट थी, रॉकेट फट गया, चला गया गलत ट्रेजेक्टरी पे, वो सैटेलाइट्स गई सारी, मिस, राइट, द सैटेलाइट्स आर लॉस्ट, ठीक है, सैटेलाइट्स आर लॉस्ट, बट वो स्टार्टअप्स की सैटेलाइट थी, आपने उनसे पैसा लिया लॉन्च करने का, उनकी सैटेलाइट लॉन्च नहीं हुई, तो उनकी वो जो कॉस्ट है, इक्वेशन समझो दोस्तों, अभी रिसेंटली एक स्टार्टअप के अंदर आई हैव बीन इन्वॉल्वड एंड certain amount was released, around 4.5 CR has been released as a fund for one of the startup, satellite बनाते हैं, उनका भी लॉन्च होगा सैटेलाइट। अब उनका सैटेलाइट लॉन्च होगा, हमने कुछ फंड रिलीज करे हैं और उन फंड्स को मैनेज कर रहे हैं कि इतना तो ह्यूमन रिसोर्स में जाएगा, इतना टेक्नोलॉजी में जाएगा, ये इतना इंफ्रास्ट्रक्चर में जाएगा, हमको लॉन्च करने सैटेलाइट, तो इतना अमाउंट आप पहले से अलग करके रख दो, ये बजट का पार्ट है। अब आपने लॉन्च के लिए वो अमाउंट निकाल के रख दिया, आपका सैटेलाइट का हार्डवेयर आपने बनाया, तो वो जो पैसा आपको दिया इन्वेस्टर ने, उस पैसे को आपने यूज करा, आपने यू डिजाइन दैट ब्यूटीफुल पीस ऑफ हार्डवेयर, और लॉन्च सर्विसेज को आप कंफर्म करते हैं, ठीक है, आई गो थ्रू फॉल्कन, आई गो थ्रू PSLV, आई गो थ्रू SSLV, मैं LBM-3 पे लॉन्च करूंगा, या मैं इलेक्ट्रॉन रॉकेट लैब के इलेक्ट्रॉन पे लॉन्च करूंगा, किसी भी लॉन्च करूंगा, और आपने फाइनल कर दिया, राइट। नाउ मिशन फेल हो गया, तो वो सारा पैसा, वो सारा एफर्ट और टाइम चला गया। जब हम बात करते हैं स्टार्टअप्स की, तो स्टार्टअप्स की टाइमलाइंस ऐसी होती हैं, 1 साल में इतना, 2 साल में इतना, 3 साल में इतना। अगर 1 साल बाद ये था कि 1 साल बाद लॉन्च होगा, हम कैपेबिलिटीज दिखाएंगे, देन विल गो फॉर द नेक्स्ट राउंड, फिर जो इन्वेस्टर है उससे हम और पैसा मांगेंगे, फिर हम इसका 4x कर देंगे वैल्यूएशन, इसका 10x वैल्यूएशन कर देंगे, तो वो सब गड़बड़ हो जाता है ना। तो इसलिए फ्रेमवर्क की भी जरूरत है। तो हमारे साथ ऐसा कुछ हुआ, तो PSLV के लॉन्च हुए, तो एक तो मार्केट में एक डेंट आ जाता है इमेज पे कि रिलायबल भी है कि नहीं है यार, ये खुद अपने इश्यू सॉल्व नहीं कर पा रहे। LBM-3 तो चलो हाँ बादशाह हो, तो उसका तो अलग ही गेम चल रहा है, बट PSLV जिसके मतलब सक्सेस रेट ऑफ सो हाई, 60 लॉन्चेस में अचानक बैक टू बैक 2, यानी वो पकड़ ही नहीं पा रहे इस चीज को। तो हम हमारी सैटेलाइट उनके साथ लॉन्च करें भी कि नहीं करें, क्योंकि हमारी मान लो 150-200 करोड़ की सैटेलाइट है, हमने कॉन्ट्रैक्ट किया है, हम 400 करोड़ रुपया दे रहे हैं ना इस इसरो को सैटेलाइट लॉन्च करने का, और बूम, तो इशू क्या हुआ, मोस्टली मिशंस जो होते हैं वो इंश्योर्ड होते हैं, इंश्योरेंस होता है मिशंस का, ठीक है। अब जैसे PSLV है, हाईली रिलायबल लॉन्च व्हीकल, अभी 2 को हटा दो, तो उससे पहले हाईली रिलायबल लॉन्च व्हीकल। तो जब हाईली रिलायबल लॉन्च व्हीकल, आपको पता है कि भाई कभी गलती नहीं होती है, तो इट्स अबाउट रिस्क। तो प्रीमियम और सारी चीजें जो होती है वो आप वैसे समझिए जैसे कि कोई अपनी एडवांस्ड एज में है इंसान, और वो बोलेगा मेरे को हेल्थ कवर चाहिए, तो उसके प्रीमियम्स वैसे होंगे। क्यों? क्योंकि पता है एडवांस्ड एज में है, कभी भी बीमारी पकड़ सकता है। लेकिन कोई बंदा यंग है और वो होता है मेरे को हेल्थ कवर चाहिए, तो उसके प्रीमियम वैसे होते हैं। यू अंडरस्टैंड दैट राइट? तो इंश्योरेंस तो यही सब होता है ना, दैट्स व्हाट इंश्योरेंस इज। तो अगर हम लॉन्च कर रहे हैं सैटेलाइट को, तो देयर आर चैलेंजेस। स्पेस इज वेरी रूड, वेरी हार्श, वेरी रगेड, वेरी टफ, ये सारी चीजें जो भी हैं। रुथलेस है, इमोशनलेस है स्पेस, डजंट मैटर आपने कितनी मेहनत करी है, गलती तो बॉम, नो सेकंड चांस। तो अब आपने अगर अपने मिशन को इंश्योर करा लिया, देन देयर इज सम प्रीमियम यू हैव टू पे, एंड इफ एवरीथिंग गोज फाइन, तो वो जो प्रीमियम आपने पे किया था, दैट प्रीमियम इज गॉन, राइट? यू आर इन्वेस्टिंग मनी कि मैं कभी भयंकर बीमार पड़ जाऊं तो मेरे को मेरा इलाज मुफ्त में हो जाएगा, कवर है, मेरे पास हेल्थ कवर है। बट डू यू रियली वांट? क्या चाहते हो कि भैया मैं तो हर साल के 10,000 डाल रहा हूँ मेरे हेल्थ कवर में और मेरे पास 2 करोड़ रुपए का हेल्थ कवर है, तो क्या आप चाहते हैं कि आप इतना भयंकर बीमार हो जाएं कि आपको 2 करोड़ रुपए के हेल्थ कवर को यूज करने का जरूरत पड़े? यू विल बी रियली हैप्पी कि आपको कभी उसको यूज नहीं करना पड़े। वो आपने एक इमरजेंसी, अनफोर्सीन सर्कमस्टेंसेज में, बैड लक ऑफ द लाइफ के बारे में सिचुएशन आ जाए, तब आपने यूज करने के लिए डाल रखा है ना? तो वही चीज यहाँ पे, कौन चाहता है कि मेरा मिशन फेल हो जाए तो मैंने जो प्रीमियम डाला है उसका मेरे को पैसा मिलेगा? ऐसा नहीं होता ना। बट देन व्हाट हैपेंड, वो स्टार्टअप्स के सारे मिशन डूब गए। कोई इंश्योरेंस की परफेक्ट गाइडलाइन और पॉलिसी थी नहीं। इसरो अपने मिशंस को इंश्योर करता है, लेकिन जो बाकी थे उनको इसरो इंश्योर नहीं करेगा। जो स्टार्टअप के थे, स्टार्टअप्स को इंश्योर करना था, दे डिडंट डू दैट। तो उनका टाइम, एफर्ट, एनर्जी एंड पैसा वो सब गड़बड़ हो गया तो वो एक डेंट आ जाता है ना। तो इसरो को बहुत वेल कैलकुलेटेड एफर्ट्स करने पड़ेंगे कि इसरो एज एन एजेंसी उनके उस इमेज पे डेंट ना पड़े, एंड द वर्ल्ड शुड लुक अप टू इसरो कि हाँ हमें तो इसरो से लॉन्च करवाना है। और स्टार्टअप्स के साथ भी ऐसा ना हो कि उनके पूरे एफर्ट ही एकदम ही डूब जाए, राइट? ओके, पीएम केयर फंड्स की तरह स्पेस एक्सप्लोरेशन फंड्स क्यों नहीं रेज कर सकती? एक आपको कटु सत्य बता दूं, 1000 करोड़ का वीसी फंड है, भारत सरकार ने अनाउंस किया था, बट वो अंडर यूटिलाइज्ड है। पता उसमें से कितना फंड यूज हुआ अभी तक? भारत सरकार ने बोला था 1000 करोड़ का स्पेस स्टार्टअप्स के लिए 1000 करोड़ का वीसी फंड है। स्टार्टअप्स को हम इन्वेस्ट करेंगे स्टार्टअप्स में, जो नहीं है इक्विटी लेंगे, आपको पैसा देंगे, आप स्केल करो, आप बनाओ। पता कितना फंड यूज हुआ उसमें से अभी तक? 2 साल हो गए सर, 2 या 3 साल, जीरो फंड रिलीज हुआ है। तो अभी तो वी हैव टू गो अ लॉन्ग वे इन दैट पार्ट की जहां पर हम इन चीजों को देखो। ओके, लेट्स सी ये क्या बता रहे हैं, सुनते हैं। 1 मिनट।
And go over to the VAB next door and get this equipment that he's very much aware of and used during the space shuttle era. And so that is in work right now. The bottom line of all this is, at this moment, the range is no-go. But that is not stopping us from moving.
No, that's not white smoke. Vapors हैं. Cryo fluid को वो करे ना, वो जो दिख रहा है, वो मतलब बादल है वो, हाँ, वो बादल है, ठंडा बहुत ज्यादा वो। Beautiful.
And goes a pretty unique situation here with trying to bring resolution and kind of help out the situation that we're seeing at the range right now. And that's the latest here from the firing room. I'll send it back to Megan and Nicole at the host desk.
Thank you, Daryl. Yes, very unique, but I think it speaks to the ingenuity of this team, right? To say, hey, we have this equipment at the VAB. Why don't we leverage it to try to solve this issue and work it?
Yeah, what a great example of human creativity, right? We know this thing exists. Let's go solve this problem. We have time, like Daryl said, we're going to continue to march down the countdown. So we'll continue to get the rocket and the crew ready, but we still have that 2-hour window. So in the meantime, let's try to figure out what's happening with the range. And
speaking of the range, what is the range for people who might not watch rocket launches with us often?
Sure, yeah. So anytime that you launch a rocket, you have to clear the airspace, right, in the launch corridor. So where the rocket's flight path is going to go, you have to make sure that that whole airspace is clear. And so we actually have assets. The Space Force helps us out with this one, but we want to make sure that there aren't airplanes in the way and there aren't other maritime assets in the way or things like that. So that there's a whole group of people. We talked to, actually, Gary said it great, right? it's a huge team sport. And so there's a whole group here on the ground that is monitoring that launch corridor to make sure it's clear and ready to go. And so if they're having issues, then we definitely can't launch this rocket. We don't want to launch blind into a corridor that we can't see.
Yeah, because as Daryl said, I mean, it is very important, the flight termination system, needing to activate it in case of an emergency. So yes, something that we will closely be monitoring throughout the countdown, and hopefully, again, won't be an issue, that they can fix this issue by going to the heritage hardware that's in the vehicle assembly building.
Right. What a great idea.
Okay, so again, under 2 hours from the opening of our 2-hour launch window, 6:24 p.m. Eastern Time. The crew, as you can see there, inside of Orion, relaxing, getting updates from the team, but also just getting in the right headspace for hopefully launch today. Let's learn a little more about each of them now.
The moon, to me, it's the thing that connects me together with all the other humans in my life. I remember being a little kid lying in bed at night and just looking out at the moon in whatever phase it was in, and I was thinking, man, my friends that live like 20 miles away, they can probably look out and see that same exact moon. And then when I was in the Navy and I would look out at the moon and I'd be halfway around the planet, I would think, man, my brother can see that moon where he is, and he's halfway around the planet from where I am. To me, it's a connection of life on Earth. We can all look up and see that moon, and it's always changing. The moon is never the same 2 days in a row. I love that. My name is Reed Wiseman. I'm the commander of NASA's Artemis II mission around the moon. I grew up in a little town just north of Baltimore, Maryland, about 20 miles north of the city. There was a National Guard base nearby my house, and there were A-10 aircraft that would fly over every now and then. I just would look up at them and be like, man, I want to be up there. I want to go do that. And then my brother went to the Naval Academy, and I would go every year and watch the Blue Angels fly during commencement. And that just started to grow and grow and grow. For a while, I wanted to join the Air Force, and then I realized Navy flies as well, and they fly from ships in the middle of the ocean. And that was it, like, done deal for me. That is exactly what I wanted to do for my career. Flying is freedom to me, especially when you're in a jet aircraft coming off of an aircraft carrier in the middle of the Pacific Ocean. Nearest land is over 1,500 miles away. So when you come off of that aircraft carrier, you are truly just alone with yourself out there. It is a magical experience to be out there all by yourself in an aircraft over the Pacific. Just it's free. I think anybody who accomplishes something that they set their mind out to, there's no one thing that does it for them. It's a combination of everything. I mean, the way my parents raised me, the way my brother and I, the way our relationship developed over time, my friends, being in the marching band, going to college, setting my own course, learning how to live on my own, being mentored along the way, being, kept on the path to success, but being given the freedom to, make excursions and fail every now and then and regroup and carry on. I think all those things come together in the end to get you where you are. I've had to overcome, I'm a human being. I've had to overcome a lot of fears. I'm pretty scared of heights. I joked about that on the International Space Station, but it turns out I'm only scared like at the edge of a building. When you're up on the International Space Station, even though you're 250 miles up, I never had that feeling of falling or that I was, at risk up there. I just kind of loved the feeling of floating and looking down at Earth. There have been challenges all throughout my life. By far, the biggest challenge was losing my wife in 2020 to cancer and now raising 2 daughters who are grown up now, but that's been the biggest challenge by far I've ever had to face. It is not easy. Being an only parent, trying to work a full-time job, and raising 2 kids is something that I think about every single day. I'm very proud of the work I've done. I haven't always done it well, but I've always shown up and tried as hard as I possibly can.
I do wonder what it's going to be like when we are really far from Earth and can see it. The sensation of being so far away from everything that you know. I had that sensation on the space station the first time I got to sit in the cupola for a really long time. So I can only imagine what that's going to be like from 200,000 plus miles away. My name is Victor Glover, and I'm the pilot for NASA's Artemis II mission around the moon. When I was in 4th grade, I was 10 years old, and that's when the Challenger accident happened. And it helped me understand how the general public felt about the astronaut corps. Right? Like, these are the people that we want to be. And that just gave me an easy thing to strive toward. The biggest fear that I've had to overcome in my life is doubting myself. Going to college when no one in my family had gone to college was a huge risk. I had more confidence in my athletic ability than in my academic abilities. I could play football with those college students that I saw on TV. But my classmates that I saw in the lab and around the University Union, I didn't know if I had what they had. I think addressing that self-doubt was a part of, swinging for the fence and trying to go get an engineering degree, not just go to college, but get an engineering degree and then go do something challenging and technical like flying. Apollo is known for sending humans to the moon. Artemis has an opportunity to continue the Apollo story, but I actually think it's important for this story to stand on its own. Artemis is a new program, and we're trying to do new things. And it's great to compare and contrast. When you look at our spaceship, you can see parts that were designed, built, and integrated in another country. When you look at our crew, you see that our crew is international. There are also men and women. And I just think that comparing and contrasting makes the story even richer. The piloting role specifically, I will have an hour and a half or so where I get to fly the spacecraft by hand. We haven't flown that many spaceships. And so the ability to fly one actually in space on a test mission is just a really unique opportunity. I can't tell you how I'm going to feel when we fly by the moon and see the moon up close and the Earth from 250,000 miles away, but I don't use the word excited because I'm focused. What we do, this is very serious and it's very risky, and we are all intimately familiar with that risk. And so if we go out there and we're successful and we can pass that baton on to Artemis III, that's something to really be excited about.
I tell a story, which is one that my dad told me before the Apollo missions when he was just a very little boy. He was looking up at the moon with his mom, and his mom said to him, "Don't worry, Ronnie, we'll never get there." Fast forward maybe 70 years later, it's his daughter that's actually going there. And I think that long arc is something that we can all learn from. The idea that the seemingly impossible becomes possible if you just believe in it and are willing to work hard and come together to achieve it. My name is Christina Cook, and I'm a mission specialist for NASA's Artemis II mission around the moon. When I look back at my dreams as a kid, I definitely never thought I would actually get here. I was very pragmatic. Even though I'm a dreamer, I knew that the odds were way against me again, so I might as well do something I'm loving in the meantime. I definitely loved science and math in school and, did pretty well in those things, but I also loved being active. I was always outside. I loved things that made me feel small. I loved looking at the night sky, oftentimes between the pine tree branches, or I loved the ocean. North Carolina also has mountains, and when we would go there, I just loved the vastness of all of those things. I loved how they made me feel and what they made me think about, and the vastness of the universe and how much out there was to learn. I'm drawn to exploring. I'm drawn to challenges that involve both mental and physical. And I'd much rather be solving problems, wearing a whole lot of equipment and in a harsh environment. And that's just something I've carried with me ever since I was a kid. Thinking about the fears or challenges that I've had to overcome, there are just so many. I mean, basically, that has been the journey. I always say to people, do what scares you. And that means I have to follow my own advice. So doing what scares me meant getting on a plane and going to the Antarctic, getting on a plane and going to study abroad in Ghana, applying to become an astronaut, opening the EVA hatch in the airlock and going out of it into the darkness, strapping myself onto a rocket. And so for me, I think that no matter what the challenge, recognizing that if people believe in you and you believe they believe in you, the challenges seem always a little bit easier. To me, the moon, it represents history. It is a witness plate. Everything that's ever happened to the moon is still written on the moon. Every single person has looked at the moon their entire lives. We see the same moon. That's something really special. It's just the epitome of a symbol of something that's in each of our hearts, but that's also represents exploration and reaching.
I have this very distinct memory of seeing an image of an astronaut standing on the moon. It's burnt in my brain because I went back to it so many times in my childhood, and I would look at that image, and I know it had a huge impact on me that humans had walked on the moon. My name is Colonel Jeremy Hansen. I'm an astronaut with the Canadian Space Agency, and I'm a mission specialist on NASA's Artemis II mission around the moon. My elementary school years, I grew up on a farm outside of London, Ontario. I spent as much time as I could with my dad on the farm. I learned the value of hard work, for example. If I wanted to go to work with Dad, it was going to be a long day, and I was going to have to not complain, or I wasn't going to get to go the next day. I had a treehouse, I had a vivid imagination, and I changed my treehouse into a spaceship. I made all these dials and controls. I had circuit breakers for switches that I found in the barn, and I was exploring space in my imagination. The most important thing I did to get to where I wanted to go in life, which was flying fighter jets and eventually becoming an astronaut, is I shared those desires with other people. And it turns out, just like you don't go to the moon on your own, if you could, I would have done it a long time ago in my treehouse as a kid, you have to go as a team. I think the biggest impediment to achieving my goals was, of course, myself. And I think that's a common human experience. There are many times where just little things would get in my way, and my immediate interpretation of that was, well, now that goal's out the window. You know, people must have lifted me back up, and somewhere in the back of my head, that persistence came through. And I think that's a common human experience, to doubt ourselves. I've come to this, I guess, realization that I believe that we all have gifts to contribute, and the goal is to figure out how to use your energy towards adding positively to humanity's existence on this planet. But I love it when humanity sets big goals, like sending humans to the surface of the moon with an eye to eventually going to Mars, because when we do that, we can bring together genius from not just even in one country, but around the world. I've also learned from my indigenous mentors that they refer to the moon as Grandmother Moon. So you've probably heard of Mother Earth. They use Grandmother Moon because Grandmother Moon is responsible for the water in their community, just like the moon moves the water around the planet, affects the tides. And I think that's a really beautiful thing for us as we go back to the moon, to think about all the different cultures around the world and how they view the moon differently. And that's really neat because we all share that same moon in the night sky.
One hour, 38 minutes and counting until the opening of the Artemis II launch window today, 6:24 p.m. Eastern Time. And we are looking at the rocket and Orion out on the pad, historic launch pad 39B here at Kennedy Space Center. What a great view, Nicole.
Yes, it is. You know, we can see the clouds out in front of us, but they are to the west. And you can see that there's some blue sky peeking through behind that rocket, which is good news.
And more people continue to come on center here. About a couple of hours ago, folks with special passes to come on center were allowed to start driving on with family and friends. And of course, we have media growing by the moment here at the press site here at Kennedy Space Center, setting up their cameras, setting up tents, interviewing folks. Again, this great jib shot that we have from our camera here showing all the interest that we have here at the press site. And actually, even to the right of us, so camera left, no, sorry, the right of your screen, left of us, plenty of other people there, set up with their own tents, broadcasting to their own viewers. And so again, just really cool to see everybody wanting to share in this moment.
Yeah, how many media tents we can see from here. It's a beautiful thing.
Yeah.
I think it's important to share this message with the whole world.
Yeah. And so let's take a look now at people who are watching in other parts of the country. We have this shot here from the U.S. Space and Rocket Center in Huntsville, Alabama.
Oh, man, look
Just
at that.
kidding. Museum of Flight, Seattle, Washington. So sorry. Hello to you over there. Sorry, I thought that you were in Alabama. But here you are from Seattle, Washington. Again, the Museum of Flight. They must have had a special event to bring people there to watch, as well as a special event here. Now, correctly, the U.S. Space and Rocket Center, Huntsville, Alabama. Of course, they would have a lot of people here, and I'm sure this crowd will grow when we get closer to launch. Marshall, the home of the SLS rocket.
Yes. Yeah, this is a great chat. You can see all the people there, and obviously you've got quite a few artifacts in there as well. Oh,
now
they
know.
Yes.
Yeah, now they know. They're on the broadcast. That's too funny.
Awesome.
Hey, listen, it's all right. We can sit and chill until we wait for the opening of the window. No, there they are.
Yeah. Everybody's excited.
Thank you guys for showing us your excitement. I know deep down it was in there. It's just that you felt like sitting at the moment, and that's all right.
There's a little delay.
Yeah, that's all right. Well, thanks so much to those supporting these watch parties and bringing them to us live here. Actually, our video paths are taking quite a circuitous route to be able to bring those live views in from Seattle as well as Alabama, but we're glad that we can be able to share it with you in the broadcast now. And so why are we going to the moon? Why does NASA want to build a moon base there? Here's Megan Carter again with our moon board.
All right. Thank you, Megan. Yeah, so we are right around that hour-and-a-half mark, hopefully for that launch. It's going to be very exciting. So they are going to have a few days to be around the low Earth orbit, and then they'll be heading on to the moon. So yes, let's talk what will be happening. Why are we going to the moon? So obviously this is not going to be a landing, as we've discussed. They are going to be coming with 4,000 to 6,000 feet around the moon's surface, and this is going to connect us directly to our past. Those Apollo missions did have 6 lunar landings, and the Artemis campaign is looking to build on that past by going back to the moon, staying longer, and then going farther. So how are we going to do that, and why? We have obviously talked a little bit about that lunar South Pole, and we are focused specifically on the far side of the moon for this one for a specific reason. You might have guessed we're going to be looking for some resources especially, and that's going to be water or water ice. That is going to be giving us some really critical pieces for future missions. And as you can see here, we have identified 9 potential landing zones. So this is going to be a critical objective for our crew. Depending on when they launch, it will determine what is going to be visible, but we do have these 9 landing zones right here around the Shackleton crater. And as you can see here, a lot of that area is deep and dark, and that is where we are going to be looking for that water ice, because that is obviously going to give us not just water to drink, but as we know, that can actually be converted into our propellant potentially, that hydrogen and oxygen. So that is going to make the moon a critical place for that moon base, because we want to think of it essentially as a backpacking trip. If you have your tent and your hiking boots and your camping stove and all your gear, you don't want to take that out and be on the trail for the first day and then try everything out. You're going to test things out a little bit closer to home before you go out on that adventure. And that kind of goes for us as well. So the moon is going to be critical for us in the future steps towards our lunar landings, and then also for going farther on to Mars in the future. It's going to set us up for that deep space exploration, and we can't wait to see what they see once they get to that flyby. But for now, we are, like I said, getting closer. So I'm going to turn it back over to you, Megan.
Exciting stuff. Again, the idea of accomplishing a moon base, like as we've been saying, sometimes things just seem like science fiction, and it's amazing that we're making it science fact.
Yes. Yeah, we're going back. We're going to scout it out, and then on the future Artemis missions, we're going to put boots back on the moon for the first time in over half a century. But we're going to stay, and we're going to learn from the moon, and we're going to, as Megan talked about, the water ice, and harness that resource, and, not only learn from the moon about Earth and about the solar system, but also figure out how we get to Mars from the moon.
And so what we're seeing now back inside the White Room with the closeout team, they are removing basically fixtures that protected the crew module hatch while they did work around it. Right, Nicole?
Yep. Yeah, so anytime that you're moving around and working, there are some sensitive sensors and parts of the crew module that we don't want to kick or bump into, and so it's easier to just put a guard up while you're working in there and then take it down later.
And so this is a visual cue for us that the team is getting ready to close the last hatch, again, the launch abort system hatch. Can you tell us about what the LAS is?
Yeah, so launch abort system, this is, we have the crew module, and then what sits basically on top of the crew module is the launch abort system, and it has its own motors, so that will arm it about 5 minutes prior to launch, and then it stays with the crew module until about the Kármán line, so that 100-kilometer point in space. Once the crew could safely get to orbit, it will actually be jettisoned, and the crew module will then be exposed. So this is just a safety mechanism that stays on the outside of the crew module, and then as they monitor the attitude and the thrust and all sorts of the roll, all sorts of different data points to make sure the crew is safely getting to orbit. And once they are safely to orbit, then we will get rid of that launch abort system.
And it looks like they're putting all these parts that they're removing from around the crew module hatch into a bag, because they have to take this out with them once they leave the pad, right?
Yes, yeah, we don't want anything left up there in the white room, and especially because that crew access arm will move away from the capsule and the rocket, and so we want an empty white room, no FOD like we talked about, so that we can have a safe launch.
And this orange tube that you see on the right side of your screen, that had been inside the crew module providing breathable air to the crew. And now again, with the crew module closed and them getting ready to close the second hatch, that has been removed and is out of the way. So again, the closeout crew can continue to do their work.
Yeah, that's just a duct to provide some cooling air and some breathing air to the crew and the closeout crew while they're in there.
That's actually a good point, yeah. And so as we continue to watch the crew prepare to close the launch abort system hatch, why don't we take a look at the crew's mission patch? Now, crews have designed their official mission patches since the Gemini 5 launch in 1965. Reed, Victor, Christina, and Jeremy, they really wanted to play on the abbreviation of Artemis II to all, signifying not only the second major flight of the Artemis program, but also a mission to explore for all, by all. The crew chose the iconic Earthrise photo for a reason. It was taken by the Apollo 8 crew in 1968, the first crew to ever fly around the moon. The mission was to prove teams then were ready to land on the moon the same way Artemis II hopes to fly around the moon ahead of a lunar landing with Artemis 4. This time, as we've been saying throughout the broadcast, to stay on the moon and pave the way to Mars.
Yeah, we talk about incremental steps, right? And so Artemis 2 is very similar to Apollo 8 in terms of that increment. They're going to fly around the moon and set up the rest of the Artemis program for landing on the moon, but also with a nod towards the fact that we do this for all humanity. And I love the thoughtfulness and how much importance they put on their patch design.
Another camera angle of inside the Orion spacecraft.
I was going to say we might be able to see Rise, but I think it's right behind Reed's foot there.
And so to orient people again, so basically we have Christina in your upper Christina in your upper left-hand corner. Then you have Jeremy below her. And then the feet you're seeing, those are Reed's feet. And then next to him, the upper right-hand corner, that is Victor, who's unfortunately hidden by Reed's feet. But again, that is the orientation of the crew inside Orion right now. Now, earlier this week, the crew got to stick their patch on a wall just outside the suit-up room. You can play that video there now. You can see that crews have been doing this as part of a pre-flight tradition again. Wow, Reed just making sure that thing won't come up.
It's flat.
And so now Victor is signing there, followed by Christina, and then Jeremy. That's a fun tradition, and your patch is up there too.
It is. Yeah, ours is on the left-hand side there. It's a fun tradition. This is a really fun day too. You know, they did this a couple days ago, but it's just another step that makes it a little bit more real that you're going to be launching soon.
Again, we talked a little bit about this before. Basically like a computer there on Jeremy's leg, a way for him to just check out the data, see some of the data that also Reed and Victor are getting to see, but in those much bigger displays for Orion.
Right, yeah, it's basically a tablet on his leg, and it's actually plugged into a cord nearby that allows him to have a screen repeater so he can see what they're looking at.
And it looks like he's taking notes. Can you talk a little bit about what that is? It's part of, all of them have like a little procedural book, right?
Right, yeah, so they have what we call a knee board, and they'll have blank pages to take notes on. They might have a cue card or procedures, or they can be kind of custom built to what each crew member wants for their knee board.
This mission, of course, built by people and companies in all 50 states, as we've been saying throughout the broadcast, and with our international partners as well. Let's take a look at some of the people playing such a big role in today's test flight.
What we're doing here is a collaborative effort of hundreds of thousands of people.
This is about the parts, the hardware, the software, the services, all coming together to make that mission possible.
My dream for this space program is that we would not just push the boundaries, but that we push them together.
And liftoff of Artemis I. We rise together, back to the moon and beyond.
It takes a team to do great things. And Artemis has an incredible team.
We have international partners. We have commercial partners and industry partners.
It takes unity to accomplish great things, and that's what this mission's all about.
We're not sending our money to the moon and lighting it on fire. We're putting that money right back into the economy in ways that benefit everybody. So every dollar that comes out of the Treasury that goes to support this mission goes back into the Treasury 3 times. What is very important to me is that we do it the right way, and that we do it with our values, that our industries grow, that our communities grow, that our families are healthy and safe and have amazing things to work on. Then we're going to build machines to go even further onto Mars.
That is our generation, the Artemis generation, that defines the starting point of our exploration future.
I just want to say thank you to all of the hands that have touched a part of this program and the hearts that have moved everyone to this goal, because we're going to the moon and we're going beyond.
One team.
One team.
One team.
One dream.
What I really like about that package is, again, just reminding people that this is spurring so many jobs across the country.
Yeah, across the country and across the world, right? The whole world has a part of this. The Artemis Accords are signed by over 40, 50 different countries. And so, yeah, we're taking all of the taxpayers' money and we're putting it right back into the jobs here in the U.S.
And the money, too. You know, when we have more disposable income because we have good paying jobs, that's money that goes back into our economy as disposable income. So really, it is just an ecosystem that NASA is proud to be a part of.
Right. And not only is it about the money and the economy, right, but it's also about the science and what we're going to learn and exploration. You know, we, on top of all of those things, we benefit the economy as well.
Mm-hmm. Obviously, Nicole is a wealth of knowledge. We're very lucky to have her. We're going to be tapping into that knowledge throughout the broadcast, and we have been for now close to 4 hours. So thank you, Nicole. I hope you're holding up okay.
Yeah, I'm loving it out here. It's been great.
Let's learn a little bit more about Nicole. Her first mission to space was actually last March. She launched from here at Kennedy Space Center as pilot of NASA's SpaceX Crew 10 mission to the International Space Station. And what a beautiful launch that was. She spent 148 days in space conducting science experiments that could benefit us on Earth. For example, one studied the physics of liquids, which could help researchers deliver medicines more effectively. She also conducted an almost 6-hour spacewalk to help upgrade the orbiting lab's power system. Nicole is a lieutenant colonel in the U.S. Air Force and flew one of its most advanced aircraft. She was born in San Diego, California, and is a twin. That's a cute photo of the two of you. Oh, that one too.
Young explorers. Yeah.
Yes. Yes. That's so great to just see how far you've come. Again, I think that speaks to what we've been saying. Like, just if you're passionate about something, go for it and see where that takes you.
Yeah, I think that's a great example. I was a serious little kid with really high goals and just kept working hard and never got bumped off the path and ended up here. And I think it's a testament to the human, like we talked about, if you're willing to work hard, be a good team player, you can really get anywhere you want in life. And that's what I love to talk about. Christina has mentioned similar things. And so it's been kind of a theme for the day.
Yeah, definitely a theme for the day, a theme for the team. The team has said the same, the crew has said the same sort of things. So absolutely, Nicole, thank you so much for being here. And hopefully only a little bit more until launch today.
Hopefully.
So today's Artemis II test flight will mark only the 7th time NASA astronauts will launch on a new NASA spacecraft designed for crew. And then controlling the flight will be Mission Control in Houston. Our Gary Jordan is inside with flight controllers. Hey, Gary.
Hey, Megan, you are right. This is a significant milestone, and we may be putting the names of a few more astronauts in the history books today. The Artemis II crew is set to launch today will join a select list of humans to fly in a spacecraft for the very first time. And Artemis II, like missions before it, is a test mission. During Ascent, the crew and the teams here in the room are prepared for a variety of scenarios. Some of these will be called out directly by Capcom's Stan Love during Ascent, and some are a little more subtle. These calls can be split into two categories: alternate main engine cutoff or MECO targets and aborts. First, there are 2 alternate MECO targets, or AMTs. These note milestones to give flight control teams and astronauts an idea of what would happen after that moment should the core stage lose one of the main engines. First is AMT low. You won't hear it called out by the crew or Capcom since this happens right at liftoff. If the core stage loses one engine at this moment, an abort once around option could be made at main engine cutoff, meaning the crew could target a splashdown in the Pacific. The second is AMT high, which will be called out by Capcom's Stan Love around 22 seconds. After this moment, if the core stage loses an engine, we can still pursue an alternate mission in low Earth orbit to accomplish some of the test objectives. And at about 5 minutes, 16 seconds into the flight, you'll hear the call 3-engine press. This is a good moment. After this point, if the core stage loses an engine, we can still make a nominal main engine cutoff and pursue a moon mission as expected. Again, these MECO targets give the flight control teams and crew an idea of what lies ahead should one main engine be lost, but assumes we are otherwise continuing to a main engine cutoff target. This differs from an abort, where the Orion capsule separates from the Space Launch System prior to the planned separation time. There are abort options at every moment that integrity is attached to the Space Launch System, from the pad to more than 3 hours into the mission. During the first 8 or so minutes of powered flight, there are 3 abort options. First is the use of the launch abort system, which you see at the very top of the rocket, and here in the White Room, where the hatch is open and teams are working to close it. This particular abort capability can be used from here at the pad through roughly 3 minutes and 22 seconds into the flight. Next is an untargeted abort splashdown, or UAS. This uses Orion's service module engines to escape the SLS and becomes available immediately after the launch abort system jettisons. Third is an abort once around, or AOA. You'll hear Capcom Stan Love call AOA open around 7 minutes 30 seconds into the flight. This also uses the service module engines, but the burn profile is a bit different to aim for a splashdown in the Pacific after one trip around the Earth. NASA's expedited recovery teams are staged off the coast of San Diego to get to the crew and integrity quickly for this abort option. An AOA option continues to be available until solar arrays are deployed on the Orion service module a little more than 30 minutes into the mission. At this point, an abort to orbit, or ATO option, becomes available until separation from the upper stage around 3 hours and 23 minutes. Mission profiles can vary depending on when an ATO is executed in that window, but with power being drawn from solar arrays, it buys more time for astronauts and flight control teams to make decisions and stay in Earth orbit, return for a splashdown, or continue to the moon. The Artemis II crew and flight control teams are well trained on all of these scenarios, and the calls you'll hear to the crew on Orion to Earth may help them be in a ready state for whatever challenge may come their way. At this time, we're not tracking any significant issues here in mission control in Houston, Texas. That would be showstoppers for today's launch. We're continuing to, of course, monitor the countdown along the way and make sure all systems are go for when we reach T0. With that, I'll send it back to you, Megan, at the Kennedy Space Center.
All right, we are ready for another reading if you are ready over there.
Yes, sir. CBA is steady at 2,600 PSI.
All right, copy that. And you know, the more times we ask you to do that, the closer we get to launch, so that's a good thing.
Copy.
You heard it there from NASA Test Director Jeff Spaulding. The more that they keep on asking her how the pressure is holding in the counterbalance assembly mechanism is a good thing, because it means we are getting closer to launch. So that's amazing news over the loops that we just heard on Orion to Earth 1. Again, that communication channel with the crew. But now I want to get back over to Daryl with the launch team. He has an update now on the flight termination system that the team was tracking.
All right. Thank you very much, Megan. And we're getting an update now from the launch team as we speak. I stand by 1 second. Okay. Sorry about that. We're just getting an update, in fact, about what I was about to report out on the range. And the good news is the range is go. So we reported that they were working to verify their equipment regarding the FTS system. And they asked for a little of that verification work to be done by one of the FTS engineers here in the firing room. He went out to the VAB to get some legacy hardware to help out with it. But in the end, this is a fix that the range had come up with to get clearance, to clear the range rather, and to as well work the FTS system. And so now they are go. Again, the range is go. That is no longer a constraint. And so you combine that with the fact that the rocket and the ground systems here also working, no constraints. Clear board here is great news. So again, the range is green, and we're continuing to work through the countdown. We got a weather update that came in to the launch director from Launch Weather Officer Mark Berger. He reported out that there's still a little bit of feisty weather activity that's happening up in the Titusville area. That's the city neighboring the Kennedy Space Center. Those showers had passed over Kennedy, and then now they're currently over in Titusville, currently still within that mile kind of constraint of flight through precipitation rule. But we're still far enough from the window that it looks like it won't be an issue. And in fact, we're seeing some good sunlight now breaking through onto the launch pad. As you can see, it's actually shining on the other side of the rocket here. But to the west, we're starting to see some of that clearing that was forecast. And so the launch weather officer held his forecast for 80% go for flight during our launch window tonight, which, as a reminder, is 6:24 p.m. Eastern Time until 8:24 p.m. Eastern Time. And we're also hearing that the last hatch closure, as you can see in the bottom corner of your screen, they're starting to work on that. That's the launch abort system hatch. There are two hatches, the crew hatch and the launch abort system hatch, and the closeout crew that you see right there, right on time with their work as they go to shut. And you can see it in motion right now, that launch abort system hatch. That's the latest from the firing room. We'll send it back to the host desk.
Thank you so much, Daryl. Great news all around. And yes, we did just see them close the last hatch. And now we are looking at a live view of Banana Creek. Lots of people there, I'm sure, relieved to hear that that issue with the flight termination system has been resolved. And we are go for launch. Go for launch from the range, go for weather, and go from all of them, I would imagine.
Yes, it's got to be exciting. The crowd is building. And as Daryl said, you can start to see the sun poking out here, and we can see all the clouds are moving north and moving away from us. So it's all good news.
And so as we know, we have our Leah Martin down there at the Banana Creek viewing location, and she's standing by with some other guests.
Hey, Megan, I don't know if you heard that huge cheer just now. Have you heard a big rumble? As soon as Daryl said that the range was clear for launch, everybody clapped. It was super excited as we get to do some final countdowns. Standing next to me, I have Hudson and Maddox, the son of brothers here. And I asked you a little bit earlier, how excited are you to be here for launch? What did you say?
I'm very excited. It's our mom's birthday, and, you know...
Not a better way to celebrate right now. I asked you on a scale of 1 to 10, how excited are you? Would you say?
11. Yeah, 11. I'm very excited. Super excited. Yeah.
So, Megan, we've been watching the launch broadcast here and hearing some of the questions that you and Nicole have been asking and answering. And I actually wanted to ask these two kids, if you could take a 10-day trip around the moon and take 3 people with you, who'd you take with you?
Well, I'd take my dad and my mom. And I mean, I don't know. Probably my best friend. I'd just say one of my friends, you know.
Oh, one of your friends. So brother got left out. Who would you take?
That was just what I was thinking. My dad and my mom and my best friend.
That's a pretty good answer. Your brother can get his own trip to space, right?
Yeah.
So I'm actually joined here also by Dad. Now, you were sharing with me that a lot of the work that you've been doing over the last several months has been prepping the launch teams, our engineering teams, our ground systems teams to get ready for launch, to be mindful and to be in this moment. How does it feel to be standing here knowing that the people you've worked so closely with are doing what they're passionate about, or doing what they were born to do, moments away from launching this rocket?
I mean, this is an exceptionally happy moment for us and all of us and the people that are, about to take off on this historic trip here. And I'm grateful to know that we've helped in some way, shape, or form to help them stay steady and calm, in such an exciting time within the agency. And so to just be here and witness it and know that, they've got some tools to help them stay calm and steady is everything to us. So.
Fantastic. Well, Megan, we are standing by ready to go, and we're ready to cheer this team on.
Thanks so much, guys. And yes, Leo, we did hear that cheer. That was very exciting. I think the vibe over there is they're celebrating, they're having fun. And here, once they heard that we're go for launch, everybody had to run back to the camera and work. It's a little bit of a different vibe, but I definitely think that people are excited, especially as we see now live inside of the White Room at the launch pad. The closeout crew has closed the launch abort system hatch. You saw there, we took it live. Took a lot of them. I think all of them, except for one. I think it took 3 or 4 of them to push that hatch door close. And then they felt around the perimeter of the door to make sure that everything was sitting just right.
Right, yeah, we talked about how heavy the crew module hatch is. This hatch is just as heavy probably. And so, they're working the closure here. And working those connections, and you can see, there's still 3, 4, 5 people that we can see in the White Room. It takes a lot of people to get these hatches closed and this rocket ready to launch.
Mm-hmm. And so the next step in the countdown is that this team will start closing out the White Room. So basically disconnecting things, stowing things, making sure that when they leave, there is nothing that isn't supposed to be there. And really, then at that point, it's just all 4 of the crew member, Victor, Reed, Christina, and Jeremy by themselves at the top of the launch pad.
Yeah, and then eventually that crew access arm will move away, and then it'll really just be them up on top of that rocket.
Mm-hmm. Yeah, your eyes lit up when I said that. That's exciting. It is. It is.
Yeah, we had a moment, we talked a little bit about my fear of heights, but most of our crew is afraid of heights. And so there was a moment where I realized that it was just us, 100 and some odd feet up and
no way,
no crew access arm. And may or may not have said something that made everybody go, huh.
Were you wondering to yourself, how did I get here?
We're pretty far up.
That crew, again, bringing that drag-on camera. That camera is a handheld camera that is a live look for teams who are remotely watching these operations closely. Again, verifying that things are as they should be before the crew starts, the closeout crew starts leaving the white room. You see them checking their procedures.
You can see they're covering the ends of those hoses. That's to protect those hoses from FOD. So we don't want any dirt or anything to get into those while we transport them and stow them. So you can see Andre there working to close out the hoses as well while they're cleaning up the white room.
And so they'll tape that close. You just saw number 5. Number 5 holding some tools. Again, we'll stow those away. You have to account for everything. Obviously, they did have tools out. They did have procedures, paper, notes out. Like all of that has to go.
Yes, and you can even see on number 3's hat, he's got a string that's connected to his suit there. Mm-hmm. That's, again, just to make sure that we don't lose anything. If, a gust of wind or you get knocked or something, you don't want to lose a single thing in the white room. So everything is tethered, everything is accounted for, and everything is protected.
The crew now, another live view of them inside Orion. Jeremy, Christina, and Reed and Victor on the right side of your screen. What do you think they're thinking right now, Nicole?
Oh man, just over an hour to launch. There's probably a little bit of a lull right now, monitoring some systems, but you can see Reed's got his feet crossed. So I think just trying to relax and, pass the time by maybe thinking through the items that they're going to monitor through the launch, the different jobs that each of them have throughout the launch. And once they get to orbit, this first day on orbit is actually really busy for them. Mm-hmm. They've got, 2 burns that they have to monitor. They've got to get the system set up and they've got to get the cabin set up. So there's a lot going on in the next 24 hours for this crew. I think they've got a couple sections where they get to take a nap, but I don't think they get a full night's rest for quite some time. So, going through what's next.
And so as we say that, imagine what it would be like to live in a spacecraft for 10 days. Let's take a look at what life will be like in Orion.
Artemis II is our first crewed mission back to the moon since the Apollo program. A lot of the focus of Artemis II is really checking out systems to be sure that we're ready and well positioned for continued human exploration. My name is Susan Baggerman, and I'm the Chief Health and Performance Officer for the Orion program and the Artemis II mission. And this is 10 Days in Orion. For this mission, the crew will launch in the Orion spacecraft on top of the Space Launch System rocket, or the SLS rocket. Once they've launched and achieved orbit, they'll continue on checking out many of the different critical Orion systems, check out some of the critical medical systems, and be sure that we understand how the crew would do that successfully within the volume of Orion. We also have, of course, systems to feed the crew. They have a potable water dispenser that they'll check out. And then we also have a food warmer, kind of looks like a suitcase that the crew can use to heat their food. They're also going to check out the flight wheel system. We'll have the crew perform some initial exercises. Part of that is to ensure that the flight wheel is actually working, but part of it is actually to be sure that our environmental control systems are actually working. For sleeping, the crew will sleep in sleeping bags. Some crew members like to be very tightly bound up, and some like to float very free. They'll use the toilet for the first time and be sure that it's able to flush. While they're on their journey, they'll do some testing that they quickly don their suit just to be sure that we would be ready in the future for an emergency. They'll also check out our radiation shelter. If we were to have a solar particle event, we would be asking them to take stowage out of the stowage bay and put it in some specific locations on the vehicle, basically for it to serve as shielding.
And And so I want to talk a little bit more about what we just heard in that package. I am interested in the space food. So Reed, Victor, Christina, and Jeremy have a pretty big menu to choose from, so that's really cool. We're actually going to pull up a graphic now that kind of shows you some of the food that they're going to have with them on their 10-day journey around the moon. We know of more than 10 types of beverages. There's coffee, a mango peach smoothie, apple cider, lemonade. So those all sound delicious. And now I've just remembered I haven't eaten lunch.
They're actually not too bad. I actually have a mango peach smoothie with me today.
No way.
Yeah. So you can see they come in these little packets here, but it's just kind of a dried powder that you add water to. So this would actually, you'd add 175 milliliters of water and let it sit for 2 to 5 minutes, and then you can stick a straw in it. You saw in that package they put a straw on the top septum portion there, and then you can drink it.
And so this is the packaging. This is food that you brought up with you, or that you had while you were at the ISS.
Yes, yeah. Actually, this is all food that we have available to us on the standard, what we call the standard menu on the space station. And so, actually, the graphic there showed quite a bit of the standard menu that they're going to take with them. So,
let's pull
space
it back
food
up,
is space
actually.
food. Yeah, we can. We can use the food that we have been using. You know, our food lab at Johnson Space Center actually creates that food, and then they stabilize it and they package it for us and everything. So they do a really wonderful job out there. We've got different types of food. You know, you can see I've got this is a soup, tomato basil soup. So thermal stabilized. It's already hydrated. So you just throw it in that food warmer that we talked about, and then you can eat it. But then we also I have some shrimp cocktail here that's, irradiated. So it's in a package that protects it. I'll show you. I've got a brownie too. That's probably my favorite one. But
are we eating it?
We might, if you're.
Yes. Look, see, they want us to eat. I don't know what happened, but it worked out. With what we were saying here.
So it's in an outer package to help protect it against radiation, and then it's in this inner package. And so this cosmic brownie, actually, the trick, Anne McLean, my crewmate, taught me. The trick is you got to put this in the food warmer and get it nice and warm, and then you can get it. But so what we do is we just take scissors and you open it up, and then it comes right out. So these brownies are nice because they don't have a ton of crumbs, and so you can actually just eat it pretty easily in space. You know, if you imagine, that would not happen in space. It would not fall. But yeah, so we've got all sorts of things that you can actually eat. The menu's pretty good and pretty diverse on the space station, and then as you saw, pretty diverse for Orion.
Nice. Yeah, that's amazing. And again, here's a look at the crowd that's starting to continue to grow here as we get closer and closer to launch. We are now under an hour from the opening of our 2-hour launch window at 6:24 p.m. Eastern Time. And so let's take some questions from social media. We haven't taken some of those for a while. You put that brownie away, Nicole, or I'm going to steal it. Nicole, we have another celebrity who submitted a question. Let's take a look.
Okay.
A quick question for the Artemis crew. What food from Earth would you bring with you into space? And why would it be lasagna? Because that's the greatest food.
Again, not really a question. Yeah. Because he was like, it's lasagna.
It's got to be lasagna. You know, there is lasagna on Space Station, and it wasn't too bad. Probably not my favorite food of all, but yeah, lasagna's not a bad option. It's a high-calorie meal. If you're trying to, carb load for a spacewalk or something, it's a great option.
Yeah. I remember Christina saying that her favorite food on the menu, and actually she was saying that she was getting in trouble because people kept on saying, you can't eat mac and cheese every day, Christina.
We mentioned the mac and cheese and brisket earlier. Man, I would put those two on a tortilla. That would be great.
That sounds delicious, delicious. Well, thank you so much, everyone, for sending in those questions. For everyone from a 5-year-old that we got a question from to all the way to Roy Woods Jr. there, a comedian. So thank you so much. And if you're just joining us, welcome to the Space Coast of Florida, where we are counting down to liftoff of Artemis II. You see a beautiful aerial shot there of our rocket on the pad. For the first time in more than 50 years, we are sending humans to fly around the moon and back, and we're taking you all of you with us on this next chapter of human spaceflight. I'm NASA's Megan Cruz, and this is NASA astronaut Nicole Ayers. Great to have you here, Nicole.
Yes, this has been a beautiful day. Excited. We're continuing to march towards this launch.
Yeah, and if all goes as planned, this crew could travel farther from Earth than any other humans before them and see parts of the moon no one has ever laid eyes on. How exciting.
Yes. Exciting is an understatement, I think.
That's true.
We're going to see the far side of the moon for the first time by humans in a long time. It's important.
And as the crowd again builds behind us, more activity that you're seeing here at the Kennedy Space Center press site. We also have a ton of people gathering around the world to watch this history-making moment. So let's take a look at those watch parties now.
Oh.
That crowd has grown. We checked with them probably like 30 minutes ago, and it was half that. But again, as we get closer and closer to launch, we are seeing more and more people gather together, wanting to experience this together and not just in a vacuum at home, you know?
Yes, this is so exciting. Look at all of those people. Man.
And now here we are back in Seattle, the Museum of Flight. Again, people gathered there to show their kid. We see someone walking in the second row there. His first crewed launch to the moon. How exciting.
That is exciting.
Hello, everyone.
Woo.
Oh, that's so great. And now let's get you up to speed on what's happened so far. Again, we are now within an hour of the opening of our launch window. So what has been happening so far today? Well, a lot. After waking up and grabbing a bite to eat, our Artemis II crew suited up inside the historic crew quarters, a tradition that dates back decades. Teams helped them into their custom Orion crew survival suits, and just like other crews before them, they gathered around a table for a card game to pass the time, but to also burn off any lingering bad luck before they walked in the footsteps of every NASA astronaut launching from Kennedy Space Center since Apollo 7 in 1968. They walked outside the Neil Armstrong Operations and Checkout Building to greet a crowd of family, friends, supporters before getting into their Astrovan for their security-escorted ride out to historic Launch Complex 39B. They got a close-up look at the SLS rocket, then walked across the crew access arm and climbed one by one inside their Orion spacecraft. After that, teams conducted final checks with the crew before closing both hatches, the crew module hatch, as well as what you're seeing there, the launch abort system hatch. And now we are back live at the pad where the closeout crew is getting ready to leave the White Room. They are now tethered, Nicole, because they are about to move some pieces that connect the Orion spacecraft to the White Room, correct?
Yes, there's kind of what I would call a shroud. You can see them working that there. So it is actually connected, so that way the gap between the crew access arm and the crew module, and well, I guess that's the LAS there, is covered. But they're about to remove that so that the crew access arm is not connected to the rocket in any way, so that it can retract here in the next few minutes.
And for how we're looking with the launch countdown milestones, let's go to Daryl Nail in the Launch Control Center.
All right, thank you very much, Megan. And as you can see there, the finishing touches, as you've been talking about, to the LAS, which brings me to that subject because we currently are hearing the launch team is working an issue that was reported out with the LAS. At least there's an issue apparently with a battery on the LAS. The engineer who is in charge of the launch abort system sits on console here, reported that a temperature for one of the two LAS batteries is out of range. And although it's not a constraint for launch right now, it would be when that temperature is checked inside of T-minus 6 minutes, which is inside of terminal count. So right now, the team is working some troubleshooting on this issue. Going to follow, of course, along closely with what they learn. But again, a battery temp for one of the two batteries on the LAS is out of spec, and the team is working to understand, first of all, whether or not this may be a sensor issue or is there an issue with the battery itself. So again, looking into it, troubleshooting and researching as we speak. With regards to the weather, we did get some good news there. Launch Weather Officer Mark Berger reporting to the launch director that the weather chances have now improved for the window. We are up to 90% go, which is great news. Again, 90% go. That is up from the 80% that we started when we had the first weather forecast come out officially 3 days ago. And so that is great. And for anybody who's here in the launch area knows that is certainly viewable. They can see that by just looking up. So we're getting some good clearing as forecast. And then just a reminder for those people who are watching the launch from the nearby area that if you're watching on an internet-enabled device, just remember that there may be a little bit of a delay. Can't tell you how much of a delay, but since it's on an internet device, sometimes this broadcast might be a little behind what you're actually seeing. So just keep that in mind as you are watching. Don't wait to the last second to run outside if you're inside your RV or your camper or your house. That's the latest here from the firing room. Of course, we'll keep track of that last battery issue. We'll send it back now to Megan and Nicole at the host desk.
Two of them there had to be tethered to the inside of the white room, because obviously now we have detached the white room from the Orion spacecraft.
Yes, that view is quite something.
Yeah, spectacular. Yep. Oh, no, I'm sorry. I forgot. Nicole's scared of heights. An astronaut afraid of heights is actually not uncommon, as we've learned today. But yes, so obviously, again, things proceeding as we march closer to the opening of our 2-hour launch window at 6:24 p.m. Eastern Time. Again, the closeout crew just finishing up those last couple of things they have to do before leaving the white room and then leaving the pad, leaving only the 4 Artemis II crew members inside the spacecraft by themselves at the pad.
Yeah, and then we'll be curious to follow the battery issue on the last as well. I think sometimes it's just a sensor issue, sometimes it's a battery issue. So hopefully they figure that out quickly.
Mm-hmm. And so if we can take a shot of the crew inside the capsule, if one's available, why don't we talk a little bit more about each of them? So we have Artemis II Commander Reed Wiseman, Baltimore native, and he's actually, you see his feet in that shot there from inside Orion. He's been in space once before as flight engineer for Expedition 41 aboard the International Space Station from May through November 2014. During the 165-day mission, Reed and his crewmates completed more than 300 science experiments in areas like human physiology, medicine, physical science, earth science, as well as astrophysics. They actually set a milestone for station science by completing a record 82 research hours in a single week. He also served as chief of NASA's astronaut office from December 2020 to December 2022. His 2 daughters were out to wave goodbye to him as he made his way to the launch pad. And again, there's Reed's feet. Reed is the one sitting in the seat to the right, closest to our camera there. So looks like he's relaxed by the body language of his feet.
Yeah, I think they're kind of in a holding pattern, if you will, or a waiting period. So it makes sense that he's a little bit relaxed. He's also kind of just a relaxed person in general. He's wicked smart, but has a demeanor that keeps everybody calm. And so I think we're seeing that here today.
And so in this shot, Reed is the one sitting on the left, and to his right, Artemis II pilot Victor Glover. NASA selected the California native as an astronaut in 2013, and at the time he was actually serving as a legislative fellow in the United States Senate. His first trip to space, November 2020, pilot of NASA's SpaceX Crew 1 mission. That was the first operational mission of NASA's Commercial Crew program, which resumed launching American rockets from American soil to the International Space Station since the end of the shuttle program. Victor is a U.S. Navy captain and naval aviator who served as a test pilot, racking up more than 3,500 flight hours in more than 40 different aircraft. So again, he probably feels pretty at home in the pilot seat of Artemis II.
Yeah, I think he does.
He got to say goodbye to his wife and 4 kids. Again, those were the family that he had here at Kennedy Space Center before the 4 of them drove out to the pad.
Yeah, and you can see there, we talked about Victor's energy earlier, and you can see him working through, pushing some buttons on the displays. Looked like he was pulling up a procedure, so he's following along and ready to go, looks like.
And then Mission Specialist Christina Cook, sitting on the upper left-hand corner of the screen there, native of Grand Rapids, Michigan, was selected to the Astronaut Corps in 2013, same class as Victor, served as flight engineer on the International Space Station from March 2019 to February 2020. During that time, she set a record for the longest single spaceflight by a woman with a total of 328 consecutive days in space. How cool. She also participated in the first ever all-female spacewalk. And before becoming an astronaut, Christina helped build space science instruments and led scientific fieldwork in some of the most remote environments on the planet. Her hobbies include surfing, rock climbing,
and
community
CDR,
service, yoga, and photography.
Go ahead, NCD.
There's a couple of suppressed overvolt messages. We're going to go ahead and clear those off your screen.
We see them and we copy.
All right.
NASA test director.
We're still working here, trying to get through everything. So we're getting close, and then trying to talk that other issue that we just picked up a little bit ago. But I think work-wise, we're doing really well.
Sounds good, NTD. We're doing great on board.
Glad to hear it.
NASA test director giving an update to the crew. Some messages flashed on their displays. Just wanted to say that they didn't have to worry about that. We're going to clear that. And then also just reassuring the crew, again, that they are tracking and working the issue with the launch abort system battery.
Yeah.
All right. And then first-time flyer, Canadian Space Agency astronaut Jeremy Hansen will fly to the moon as mission specialist on the Artemis II mission. The London, Ontario native selected as an astronaut in 2009. After that, he worked as Capcom at NASA's Mission Control Center in Houston. Capcom stands for Capsule Communicator and is the sole direct voice communicating with astronauts while in space. Jeremy also participated in training exercises, really cool ones, like living on the ocean floor off the coast of Florida to simulate deep space exploration for a week. In 2017, he became the first Canadian to lead a NASA astronaut class. He also enjoys getting out on a sailboat, rock climbing, and mountain biking. He has a wife and 3 children. And he's the one that you see bottom left-hand corner of your screen. I know, I'm trying to see what he's doing there. Christina's looking too. And so there is your Artemis II crew inside the Orion spacecraft. And this is actually the 7th time NASA astronauts will launch on a new NASA spacecraft designed for crew. And if you're wondering about the first 6 crewed test flights, here they are. Gemini 3, Gus Grissom, John Young, March 23, 1965. Apollo 7, Wally Schirra, Don Isley, Walt Cunningham, October 11, 1968. Space Transportation System, or STS-1, John Young, Robert Crippen, April 12, 1981. Then NASA's SpaceX Demo 2, Doug Hurley, Bob Behnken, May 30th, 2020, followed by NASA's Boeing crew flight tests. Butch Wilmore, Sonny Williams, June 5th, 2024. And now, Artemis II with Reed, Victor, Christina, and Jeremy. It is really surprising, honestly, to hear that through all these decades, through all these launches we've had, this is only our 7th new vehicle that we're testing for crew.
Yeah, you know, we have so many different missions that we think about and we talk about, but really 7 vehicles that we've tested and that we're flying. You know, I like to think of spaceflight really as a permanent test, right? We have, you know, hundreds of missions or so. You know, an airplane that gets tested and then flown has thousands of data points. And so really spaceflight is always going to be in the test field. And I think it's important to remember that, especially as we put humans on rockets that we never have before, or for the 7th time we start a new vehicle and a new mission.
Just getting word now that White Room closeouts are complete, and so the closeout crew is preparing to leave the pad.
It's exciting stuff. We are making good time, and the closeout crew is doing really well.
41 minutes, 43 seconds and counting until the opening of our window. And Artemis II is a 10-day mission that will send the 4-person crew on a journey around the moon and back to Earth. It will be a critical step towards future lunar and Mars missions.
We're going back to the moon because it's the next step in our journey to Mars. We need to go explore the moon. There's vast regions of unexplored areas with the coldest, darkest places in our solar system. This is a test mission, and when we get off the planet, we might come right back home. We might spend 3 or 4 days around Earth. We might go to the moon. That's where we want to go, but it is a test mission, and we are ready for every scenario as we ride this amazing space launch system and the Orion spacecraft.
But another reason we're going back to the moon is to fulfill NASA's mission, which is to explore the unknown in air and space, to innovate for the benefit of humanity, and to inspire the world through discovery. And when we succeed and when we accomplish the things that we set out to accomplish, that inspiration not only can set up new things to happen, but it also is a reminder in tough times that we're capable of doing great things when we work together.
The thing I love about the moon is that it's not just a beacon for exploration and this platform of possibilities for incredible missions like this, but it has benefits. That's actually why we're racing towards it. Those benefits are really wide in nature. You have everything from innovation, technology development, not only for future missions going deeper into the solar system, but technologies that come back to Earth. You have inspiration, a whole generation of people starting this pipeline of STEM workers and manufacturers and operators that are excited to see what you can do when you work hard and you come together as a team.
When I think about the 4 of us flying around the far side of the moon, seeing that Earth rise, taking images and video and sending them back to you, the feeling that I have inside is hope. We know that Artemis II is not the solution for humanity on planet Earth, but it is a contribution in the positive column. We hope that just for a moment that people will pause and say, wow, it's extraordinary when you look back upon the Earth with over 8 billion people, and you see this concrete example of what humanity can do, this extraordinary thing when we set big goals
and CDR NTD
to achieve them.
And so Mission Control Houston will control the flight of Orion after a liftoff here at Kennedy Space Center. Here's Gary Jordan, who's embedded with that team. Gary, you might have to pause because we did just hear a call out to the commander in Orion.
Will do, Megan. I think that was Commander Reed Wiseman responding to prepare for some of the next steps. We are now holding at the T-minus 10-minute hold. Expected a 30-minute hold. So we are well on the countdown. We are well on the timeline to meet this L-minus time and launch towards the beginning of the window, but continuing to track progress along the way. Again, I'm here with the Artemis II flight control teams in Mission Control Houston. The team in the room behind me has been monitoring the countdown and verifying their own mission-specific launch criteria of the Space Launch System, the Orion spacecraft integrity, and its crew. During the final poll before launch, if all looks good from each of the flight controllers in this room, Flight Director Judd Freeling will report a go for launch from Houston Flight. Upon liftoff, teams here take control of the mission and communicate with the crew while they fly on the Space Launch System. This phase of flight is highly dynamic, and each console position has a dedicated and important role of looking after critical systems. You'll hear calls from Capcom and NASA astronaut Stan Love in this room to the Artemis II crew as milestones are reached during the more than 8 minutes of powered flight on the core stage. Liftoff and Ascent are just the beginning. This room will be staffed around the clock over the next 10 days to oversee every moment of the mission through splashdown. Here from the Johnson Space Center, we'll be streaming the mission live 24/7 so anyone can follow the crew's journey, take peeks inside the spacecraft, and share the experience of a lunar flyby with astronauts looking down at the moon's surface. Teams here have been rehearsing tirelessly in simulations to throw every conceivable and inconceivable scenario their way. We are ready and eager to begin the Artemis II mission. Still milestones to come as we continue the countdown, but we'll be right back with you during the ascent phase of today's flight. With that, Megan, I will send it back over to you at the Space Coast.
Thanks so much, Gary. Under 37 minutes until the opening of our 2-hour launch window, 6:24 p.m. Eastern. I've never been more excited for a time. But why don't we send it back over to Megan Carter with the Moon Board to learn more about what happens after ascent.
Absolutely. I am definitely also getting excited. Things feel like they're starting to pick up a little pace here. A lot is about to happen within the first 10 minutes of launch, but what happens after those first 10 minutes? Let me take you over here to my mission map so we can kind of jump ahead and let me explain a few things. So, our main engine cutoff is going to stand for MECO, and that is essentially where the rocket's job is done, and it is then going to turn the propulsion duties over to our ICPS. That stands for Interim Cryogenic Propulsion Stage. Don't try and say that too many times fast, but the ICPS is going to be right here, and that's our in-space propulsion. About 50 minutes into, after about 50 minutes into launch, it is going to conduct that first burn, and that's going to be the perigee raise maneuver. Essentially, what that is going to do is going to raise the spacecraft from a lowest point of Earth just a little bit higher into space, and then they are going to conduct that nice path that's going to set them on that nice circular path around the Earth. That's when they're going to start to be able to really check out the spacecraft. The Orion spacecraft is going to be able to, like we've talked about, be maneuvered by the crew. They're going to check out those life support systems, and communication checkout's going to be vital at that point as well, obviously. Then they will be conducting that another burn, and that's going to raise them just a little bit higher again, and then they will it'll be about time for the ICPS to separate, and they will start another lap around the Earth as well. Now the ICPS, but even after it separates, its job will not be done because they will have the opportunity to conduct something called the proximity operations demonstration, and this is going to be really important for our future lunar missions because the ICPS actually has a target on it, and the crew is going to have the opportunity to manually maneuver these spacecraft like we've mentioned and practice those docking maneuvers. Now obviously they will not be docking for this mission, but that is again going to be critical for those lunar missions in the future. Now, all right, after that ICPS has separated and they've done that second lap, they're going to conduct 2 more burns. And what these burns are going to do is set them up to the high enough orbit and a fast enough speed in order to conduct the translunar injection. This is going to be that critical moment and that critical milestone where they are going to produce about 6,000 pounds of thrust. And this is that point that is going to take them out of low Earth orbit into deep space, and it's going to set them on that nice path towards that lunar flyby. And I know we have talked a little bit about why this could be a record-breaking flyby and journey to the moon. And with that, I'm going to turn it back over to Megan so she can tell us just why.
Yeah, she's talking about the distance record set by the Apollo 13 astronauts in 1970. They were 248,655 miles away from Earth, and this Artemis II crew might surpass that on flight day 6 when they fly around the moon by more than 4,000 miles.
Yeah, it's a long ways. It's tough to fathom 250,000 miles from Earth, right? I mean, space, the space station is only 250 miles, and so we're going, I don't want to do the public math, but we're going much further than that. But it's important, right? Because we want to get back to the moon. We want to see the surface. We want to see the far side of the moon. And the way we do that is by breaking distance records.
Yeah, and the exact distance record depends on exactly when they launch, like the time, the day. So we'll learn more as we go into this 10-day mission with the Artemis II crew. But here we are, 32 minutes, 50 seconds and counting from the opening of our launch window. Feels really, really surreal here as more and more people come to gather on the press site lawn here at Kennedy Space Center. Why don't we take a look at this video that we have here? Some familiar faces who wanted to wish our Artemis II crew a safe journey.
Reed, Victor, Christina, and Jeremy, you are the real deal. You're flying to the moon for all of us, and we are in awe. You're the true heroes.
You are not just astronauts. You are pioneers, venturing deeper into the unknown. But you are not alone. We will be all cheering you on from planet Earth.
Hey, I'm Victor Wembanyama, and I play basketball in the NBA. But I'm not only interested in shooting hoops. I'm also interested in shooting stars, dark matter, and all other types of astronomical phenomenon. And to the Artemis II astronauts who are shooting for the moon, I wish them good luck and Godspeed.
Hi everybody, I'm Ryan Gosling and I play a biologist who goes to space to save the planet in the film Project Hail Mary. But the Artemis II astronauts are going to space for real and they will travel farther from Earth than any humans in history. Sending all our best wishes to the Artemis II crew.
I just want to say how proud I am of each of you and how inspired you make me. But it's not just about me. Your mission is going to inspire future generations of scientists, engineers, athletes, and dreamers to do something that they never thought possible.
Hey, it's Roy Wood Jr., and I want to wish the Artemis II crew a happy and safe journey to the moon, well, around the moon. To go around, I know what you're doing. You got to look for a parking space. This is to go around the moon, make sure it's somewhere to park, and then you park journey. Good luck.
It's actually a really good way to explain what how this mission builds. Again, we are hoping to land astronauts on the surface of the moon in maybe 2 years. So yes, we are looking around the moon on this lunar flyby mission to see where we might park. Thank you, Roy Wood Jr. Okay, and as we look at this live view of the rocket on the pad, there is a spectacular place here at Kennedy Space Center to watch launch from, and that's the Banana Creek viewing area. Why don't we go back there where the crowd is excited and Leah has the best assignment ever, talking to people who are super excited about being here for Artemis II.
Oh my gosh, Megan, you talk about the excitement being palpable. I'm telling you, everybody here on pins and needles as we get just about half an hour away from launch. I've been walking around talking to people and I'm just struck again and again by how many people are here from across the agency. I want to introduce you to just a small portion of the people across NASA who have been supporting this mission.
Patty Ortiz, NASA Armstrong Flight Research Center, Orion program.
Orion.
Kathy Graves, Glenn Research Center, Office of STEM Engagement.
David Alexander, NASA Glenn Research Center, Office of STEM Engagement.
Jennifer Becerra, Johnson Space Center, the Office of STEM Engagement.
Here we go. Right back here. Where are you from?
I'm from NASA Glenn Research Center, Joseph Panakitis.
Joseph, here we go.
Wes Furman from APL.
Maria Arredondo from Headquarters, Next Gen STEM.
Mark Robinson, Stennis Space Center, Commercial Space.
Amira Flores, Armstrong, Office of the STEM Engagement.
Molly Kearns, NASA Glenn, Space Communications and Navigation.
Matthew Pierce, Goddard Institute for Space Studies in New York City.
Here we go, and right over here.
Lauren Ring, Ames Research Center, Data Integration.
So we're coming together. We're one big NASA team, one big NASA family, and we have one major message before we launch tonight. Okay, guys, what are we going to say? 1, 2, 3. Go!
Oh my gosh, that made me so emotional. That was so inspiring to see. I mean, wow, yeah, that was great. I mean, just to hear everybody say their position, what they're doing to support this mission is amazing. And I'm sure this was something that really rang true and resonated with NASA's Administrator Jared Isaacman, again, to see the workforce come together to do the work and then to be here for launch. So why don't we actually go over to him now with our Jasmine Hopkins at one of our other viewing locations.
All right, Megan, thank you so much. The energy here on the balcony is honestly becoming electric as we get so close to launch. And now we are thrilled to welcome NASA Administrator Jared Isaacman. Jared, we're really entering a golden age of exploration. How will Artemis II set the pace for the coming years?
Well, I mean, Artemis II is the opening act, right? This is the test mission. This is getting very comfortable with the SLS rocket, the Orion spacecraft. No humans have ever flown on this before, right? And we're going to put it through its paces. We'll go into Earth orbit for a little bit, make sure Orion's doing okay, and then we are sending them, right? We're going to send them farther into space than any humans might have gone before, 250,000 miles away, and it's going to set up for the subsequent missions. That's why we're going into the golden age of science and discovery right now, because you're going to see a moon rocket launch in 2027 when we do our testing with the lander. We're going to go for the landing on Artemis IV in 2028, and in parallel, we're going to build the moon base, right? And that is going to be filled with science discovery and tech demonstrations that's going to support the enduring presence we're trying to create on the surface.
Absolutely. So honestly, history-making years ahead of us, with Artemis 3 and 4. But first is Artemis 2. What will be our single greatest takeaway from this mission?
Well, I'll tell you, I mean, after ignition, to me, the moment that I'm going to be most excited for is splashdown. There's no question about that. Good shoots coming down off the West Coast. But look, I think the takeaway from this is gaining extreme comfort in the Orion spacecraft, right? I mean, this is very different than what we've done for more than a half century, right? I mean, the velocities that spacecraft is going to re-enter at, it's going to be new territory for us. We want to get our arms around that completely. So I would say the performance of SLS plus Orion is everything on this one. We want to make sure we do it in as a safe way as we possibly can, understanding what we are undertaking right here. Bring our crew back, learn as much we can from the vehicle, set up for Artemis III in 2027.
Right, and Administrator, we've actually had a pretty young audience today here. Some kids running around the balcony. How do you hope Artemis II inspires that next generation?
I talk about this all the time. One of our overarching KPIs that we should always be tracking is the number of people living and working in space. Well, what's another strong number 2 on that one? It's the number of kids that are dressing up as astronauts for Halloween, so that they grow up, that they're inspired to want to join in this grand endeavor, whether they come work with us here at NASA or they join in industry, but they're helping humankind venture out farther, pursue all the secrets of the universe.
Yeah, I think we'll see a lot of kids dressed as astronauts this year. And finally, Jared, you've really made it a personal mission to get to know the people behind the work at NASA. Do you have any final thoughts, any final words before today's history-making launch?
Yeah, well, one, I want to express a lot of appreciation. I'll tell you what, the 4 astronauts on top of Artemis II know this. It takes an army to pull a mission together like this, right? Across all 10 of our centers, all of our commercial partners, the international partners that come together to make this possible. My sincere appreciation for everyone who is currently working the mission right now, so getting them ready for launch, that will be watching over them in mission control, recovering this crew when they splash down off the West Coast. I have complete trust and confidence in your abilities. And everybody else who's not directly working on Artemis II, Artemis III is coming up next year. When this mobile launcher gets back in the VAB, we're going to start stacking.
Wow, plenty of excitement ahead of us. Jared Isaacman, thank you so much for being here.
Thank you. Thanks for being here.
Of course. All right. And with that, let's get back to the countdown with NASA's Megan Cruz.
Under 25 minutes and counting from the opening of our 2-hour launch window, and take a look at all these people behind us. I literally, every moment I turn around and I see the clock, I am like, oh, wow. Oh, wow.
There are more people and less time.
Yes, exactly, which is a great problem to have. Yes. Now, this first crewed test flight of NASA's Artemis program coincides with the 250th anniversary of our country's founders signing the Declaration of Independence. Exploration is a part of America's DNA, and it continues now with our return to the moon.
250 years ago, 13 colonies laid the foundation for the greatest and most enduring democracy in the history of the world. One driven by courage, faith, and freedom. From that moment, we became a nation defined not by where we stood, but by how far we were willing to go. We conquered vast frontiers, invented tools that shaped a modern world. We found light in the dark, and we rose from the earth. Faster, higher, farther. We pushed beyond the sky and into the unknown. We carried our courage into the cosmos, and we planted the American flag on the moon, the defining achievement of American superiority in space. Today, our curiosity stretches farther than ever. American robots search ancient rivers on Mars. New telescopes unfold to glimpse the first stars. And a new generation prepares to return to the moon, this time to stay. For 250 years, America has carried the light of humanity forward. But American exceptionalism isn't inherited. It's earned. Our greatness comes not only from what we've done, but what we're still determined to discover. Because in every era, across every horizon, America is at its best when it's reaching for something greater. America celebrates 250 years, and we are leading the world into the future.
"22 minutes, 15 seconds and counting from Artemis II, NASA's boldest test flight in a generation. The crew has said this often, that they hope it inspires children around the world. And recently, a group of kids here at Kennedy Space Center got a surprise of a lifetime while watching that rocket roll to the launch pad.
So tell me what color it is. And who's going to be on that rocket?
We're going to be on that rocket. I could make it a little bit longer. Did you see it? Okay, so everybody's looking at the rocket because it is kind of cool and impressive. One of the coolest things happening over there right now, though, is it's on top of a giant tractor.
Doesn't all food come in like tubes? It's in these like little plastic bags. You have to like rehydrate it. Sushi. There's not. I haven't seen sushi in space. It's probably hard to keep that back.
Sushi mashed together.
My favorite part was this one little girl, she had a question. She had patiently held her hand for a long time, and Christina turns to her and says, "Okay, what's your question?" She just goes, "I forgot." It was like, that's a perfect little kid moment. I just love it.
Wait, are you my mother's cartoon astronauts?
What? Say that again?
Never mind. It's a little hard to say. Go Artemis!
These two?
Yeah. Put it on.
Yeah. There you go. I like your dabbing astronaut back there.
It's just so fun to see the enthusiasm, the energy, and a little bit of chaos.
3, 2, 1.
Wasn't that so cute?
I love kids and their excitement and, you know, even just being real. Like, I don't remember what I was
know. He goes, but I'm glad you're here. Now, here we are, Space Center Houston. The crowd has exponentially grown throughout the day. We started showing you live shots from in there probably an hour ago. And now take a look at all the people there getting ready to witness history together. It's something really special to be able to witness something like this together.
Yeah, you know, we've heard from celebrities and officials and kids, and, you know, it's amazing. People from all around the world came here today to Florida to watch. So it's something, it's hard to put into words, just how much support for this mission we're seeing today.
And great news, too. Remember, the team was tracking an issue with the launch abort system battery. They appear to have cleared that issue, so we are go for launch.
Yes, it's exciting.
U.S. Space and Rocket Center here, Huntsville, Alabama, waving to the Artemis II crew sitting right there inside Orion. Inside of 20 minutes from the opening of our launch window, and right now we are targeting the top of that launch window, so we could be launching here in about 19 minutes, Nicole.
Wow, I don't know if I expected this today. I'm excited, and, you know, I'm glad they were able to clear the problem with the battery on the LAS, and everything has gone really smoothly today. It's been great. The weather cleared up. It's a beautiful day for a launch.
And so now, as we are so close to possibly launch now, just what are your final thoughts as we are about to embark on a mission back to the moon, the first time in more than 50 years?
Yeah, you know, just so proud of the crew and all of the teams here on the ground that made this happen. You know, they are carrying the torch from the Apollo era into the Artemis era. And, you know, it's the crew likes to say they want to be the shoulders that the next generation.
And let's see, GLS, can you help us with that, please?
They want to be the crew wants to be the shoulders that the next generation can climb on.
001.
You know, I think it's in their patch. We're going for all. It's in the name of their capsule, integrity, representing humility, and the professionalism of everyone that got them there today. So proud of them. We love them. We're excited for them, and we cannot wait to see what they see.
Just leveraging everything we've learned so far as an agency, taking us from Apollo now to the launch pad here, 39B, with Orion and SLS poised to again fly us into the history books. And before we leave you now here at the host desk to get back into operations, we just wanted to answer one question for you guys. We asked you earlier on today, what are you most excited for? And we asked you to go vote on Instagram and Twitch. Instagram, you guys said launch. Twitch, you guys said lunar flyby. So I think you guys will all be very excited since we are now about 17 minutes from the opening of our launch window today. And so with that, as we approach terminal count, let's send it back to Daryl Nail in firing room 1. Daryl.
All right, thank you, Megan and Nicole, and just want to give you an update on the launch abort system that you just reported that they cleared. They believe, they're convinced, this is an instrumentation failure. So there are 2 batteries on the LAS. The LAS, of course, and with the help of my 2-year-old son's model rocket, Daniel said I could use this, so it's okay. The LAS is right here. It's the tower above Orion. Orion capsule's inside of here. It's used to pull Orion off the rocket in case the rocket is something's going on with the rocket, either on the pad or in flight. 2 batteries are bad. Well, I'm sorry, one of the 2 batteries reported an out-of-family temperature, and it was very much out of family. And so they checked their data going back into the vehicle assembly building where they recharged the batteries and worked on them. And they have good, solid data, they reported, that tells them that this is an instrumentation failure, that there's something wrong with the sensor. And so they took it before the mission management team, which has to accept the risk, any changes to launch commit criteria, which this would be one, and they all fully accepted it. So now we are clear as far as that constraint is concerned. And one quick thing as we count down now, we are getting into the final minutes before liftoff. There's a 2-hour window. We haven't quite set the T0 yet, but this is a list of the cutouts. There are 150 cutouts that are included for this 2-hour launch window. And that's important. They're in very small print. That's important because there's basically 16 minutes inside this window that they cannot launch. And these are because of small things flying in orbit. There's a lot more things in orbit than there were back in Artemis I when we had 35 to 40 cutouts. For that reason, because of these 156 cutouts, they're going to be managing the launch window as we go forward. So they may have to wait out one of these cutouts. They range in time between 2 seconds to 23 seconds, but you'll hear the NASA test director talk through that. We're getting ready to merge that loop from NASA test director Jeff Spaulding. And so now I'm listening to the launch team get ready to merge their operational channel. We're now entering one of the most consequential phases of launch day, and that's terminal count, the final 10 minutes.
And OTC, NTD on 212 for comm check.
Good comm. How me?
I hear the same. STC? GTC?
GTC is on 212.
All right, copy that.
NASA Test Director Jeff Spaulding confirming communications with his team. There will be 2 polls that we'll hear. One from Spaulding, the NASA test director, confirming the ground systems and the launch team are ready to proceed. At this point, we have a clear board, no constraints, but we need confirmation from each individual on the NASA test director team. So we'll hear him poll his team. The other poll that we're waiting for is the poll from Launch Director Charlie Blackwell Thompson, who will take that final status from NASA management before giving the go to come out of a hold. And you're seeing the clock count down at L minus 12 minutes.
CCL, OTC, Orion, RS1.
CCL.
Yes, sir. Reconfigure ARS primary loop ISO valves.
Copy, that's in work.
And CDR, OTC, Orion, Earth 1.
Go.
ARS loop ISO valves are being closed at this time.
Integrity copies.
NGDLP.
Go.
Yes, I had a discussion with Sea Ice and with MER Manager regarding the observation the Sea Ice had a few minutes ago. They were able to confirm with BCI photos that the condition that they observed has been there since 2025. MER Manager has had a chance to review the findings, and they do not have any constraints from either a Sea Ice or MER Manager perspective.
Okay. Copy all. And Launch Director, NTD, you copy?
Yes, sir. I copy. That's good news.
OTC, CCL 212.
OTC.
ARS primary loop isolation valve configuration is complete.
Copy.
And CGLS NTD, cancel pending, please.
GLS copies, and that's complete.
All right, and for all personnel, we got a little bit more work to do before we pick up the clock, and we're about a little over a minute from getting to T-minus 10 minutes, but we've canceled the resume time there, and then we'll pick it up after we get through all of our work and anything else that we need to do to get through the remainder of count. So we'll continue working that to get to our T0 today. So when we get to about 50 seconds from now, we'll extend that hold.
CVSE OTC.
CVSE 400, 290, looking to verify that we are configured for Ascent. Yep, give me about 2 more minutes. I'm going to start CMA2 streaming. Copy.
NTD, COSE, hold requested.
Copy that.
I have an LCC violation of O-CT-004. S-band transponder anomaly. This was a transient LCC violation, so transponder 1 had a demodulated SNR estimate that went down to 2 dBm when it should have been between 10 and 13. It is now back up to 12, but we did lose that for just a moment. It does not appear that we lost our bit sync or carrier lock, which would be indicative that we lost our lock with the vehicle. So at this point, recommendation would still be go. However, we do have a pre-planned contingency procedure if we want to look at that. But again, this is transient, so we're back in a nominal range.
All right, let's see. LPE NTD.
Yeah, we're not seeing that hit. So I guess the question for COSE, was that less than 3 samples? Is that below our persistence?
Stand by. Let me look. It did look like it did persist for several seconds on mine, but let me take a look at the number of samples.
Could I get a repeat on the affected LCC, please?
Yes, ma'am. That's going to be O-CT-004.
Thank you.
Yeah, us taking a look at the data right here, looks like that was a single sample.
Yeah, copy that. RFTS does report that they also lost lock for about 5 seconds. So I would love to ask KUS and see if they also lost lock with the vehicle for any extended amount of period.
And COSE, while we're doing that, these are 1/10 hertz measurements, correct? So we would have had to lose it for over 10 seconds to get a second sample?
Yes, sir, that's correct. It is 1/10 hertz.
Yeah, so from our perspective, the allowance is effectively up to 30 seconds, up to 3 samples based on the 1/10 hertz. This is not an LCC violation, I believe.
Yes, sir. I would agree with that at this point. Copy that.
We're checking with KUS on 232. I don't think they have 212 access. We're trying to verify, but it sounds like they have a loss of lock as well. About 2 seconds.
Okay. And I guess for both KUS and COSE, do we have lock now?
That's affirmed. We do have lock for COSE.
Yeah, so from the integration console perspective, we did have a temporary loss there within the allowable, and per the requirement, let's go.
And this is Houston Flight. We have lock and we have good telemetry here in GSC.
And KUS has reported too, they have good lock now. So with all of that, OSC, then are we in a go configuration per your LCC?
Yes, sir. Recommendation would be go.
Okay. LPE, you concur with that?
Yes, sir. LPE concurs go.
And Launch Director?
Yes, sir. Launch Director concurs go.
All right, and I'm going to go ahead and just verify everybody has everything else complete, Launch Director, and if we do, we'll be ready to pick up the poll at that time, unless there's something else that you're aware of.
No, sir. Let's verify all our work is complete, and I would like one last check of our constraints list.
All right, let's see. OTC, are you still waiting for ComConfig, or are you...
That is affirmed, sir.
Okay, yeah, you only open item?
Yeah, OTC, this is CVSC. That 400 step 290 is complete.
Copy.
Okay, so OTC, you're complete with all of your work?
That's affirmed.
All right, copy that. STC?
STC is complete.
And GTC?
GTC is complete.
Okay, excellent. All right, and LPE, just want to verify we have no open constraints at this time.
No open constraints. We have a clear board, sir.
Okay, tracking the same here. And Launch Director, with that, we are clear and ready to pick up the launch readiness poll with your go.
All right, sir. I am go for the poll.
All right. And for all personnel, this is the NTD conducting the Artemis II launch readiness check. Verify ready to resume count and go for launch. OTC.
GTC is go.
STC.
STC is go.
GTC.
C's go.
MCO.
CO is go.
Safety Console.
The Safety Console is go.
LPE.
LPE's go.
RTD.
RTD's go.
Houston Flight.
Houston Flight is go.
ROC.
ROC is go.
And CDR.
Crew is go.
Copy that. Thank you, Reed. And Launch Director, NTD, our launch team is ready to proceed at this time.
All right, NTD, I copy all. At this time, I'll perform my poll. Attention on the net. This is the Launch Director performing the final poll for launch. Verify no constraints and go for launch. EGS, Program Chief Engineer.
Artemis Chief Engineers are go.
Copy, thank you. EGS, Chief Safety Officer.
The Artemis CSOs are go.
Copy, thank you. Range Weather.
Launch weather is go.
Thank you, LWO. And Artemis MMT Chair.
MMT's go.
Thank you, John. And Integrity Launch Director.
Good air voice, Charlie. PLT.
Thank you, Charlie. This is Victor. We are going for our families.
MS1.
This is Christina. We are going for our teammates.
MS2.
This is Jeremy. We are going for all humanity.
All right, Charlie, your Artemis II crew is go for launch. Full send.
I copy that. Reed, Victor, Christina, and Jeremy, on this historic mission, you take with you the heart of this Artemis team, the daring spirit of the American people and our partners across the globe, and the hopes and dreams of a new generation. Good luck. Godspeed, Artemis II. Let's go. And NTD Launch Director.
Go ahead, Launch Director.
Yes, sir. You have a go to proceed with countdown.
Copy that. I'll put it in work. CDR, NTD.
Go.
Gear risers and initiate short purge per your EPROC 10.1.1, steps 8 and 9.
10.1.1, 8 and 9 going to work.
Copy. CVSC, NTD. Start and verify recordings of our Orion cameras.
Copy.
Okay. Well, there you heard it.
RSR, NTD.
RSR.
They're getting ready to start terminal count.
arm rotation enable at this time, please.
It's currently at T-minus 10 minutes. Once we wrap up this last bit of work.
SNA arm rotation enabled complete.
We're going to start that clock.
Copy that. Thank you.
Integrity crew, close and lock visors.
You heard an issue, worked in real time with telemetry lock on the Orion. It was transitory. It was very short. They checked the data, confirmed that they had a good lock. This was with the S-band transmitter on the Orion. Worked through that issue, looked at the data, and cleared it. All with the world watching. Impressive work by the launch team. So we have a 2-hour window, which starts in just a few minutes at 6:24 p.m. Eastern Time and goes until 8:24 p.m. Eastern Time.
And ECL NTD will be waiting for your verification on the short purge.
ECL copies.
And for all personnel, once we get that short purge verification, we'll verify that we are clear to go, and then we'll proceed with the terminal count. ECL time estimate?
About a minute.
Copy.
So we're going into the launch window, but not by much, it looks like. Just wrapping up some final work. And once that's completed, you'll hear NASA Test Director Jeff Spaulding ask for the ground launch sequencer operator to go ahead and start the clock. The ground launch sequencer is an application software. It runs on top of the launch control system in the firing room, acts like a conductor of an orchestra, executing hundreds of commands in precise order and timing. It's all autonomous.
NTD CCL 212, short purge initiations verified.
All right, copy that, and we're verifying our constraints. All right, and we're clear from cutouts. And with that, we're going to resume the clock momentarily. And CGLS, you can resume the clock on your mark.
GLS copies. 3, 2, 1, mark. GLS mainline has been initiated.
T-minus 10 minutes and counting.
And that begins terminal count. Our new T0 is 6:35 p.m. Eastern Time. 6:35 p.m. Eastern Time. We are now counting down to liftoff of Artemis II. From now on, you're going to hear two voices on the loops. If everything goes nominally, NASA Test Director Jeff Spaulding, who's directly managing the launch team, and Alex Bendelos, the GLS operator who closely monitors the software. He has the ability to stop and restart the countdown. A lot of people ask about whether there's a launch button. There certainly is not.
Flight and rock. Our new T0 is 22:35:12.
Houston flight copies.
Rock copies. 22:35:12.
Affirm.
There you heard confirmation of the exact T0, 6:35 and 12 seconds p.m. Eastern Time. Again, our T0 is 6:35 and 12 seconds p.m. Eastern Time. But as I was saying, there's no launch button. This is autonomous. But there is a button that keeps you from launching, and that button allows the GLS operator to pause the countdown outside of terminal count and during terminal count and submit a hold to the next holding point. So the clock won't stop right away. If there's an issue, we'll go to the next stable holding point. This is how GLS configures the rocket and ground systems to a stable point where they can stop the countdown if that's needed. But right now, we are counting down. Our next big milestone, looking to retract the crew access arm.
GLS is go for crew access arm retract.
And there you see the crew access arm moving away. That's the path that the astronauts took to ingress into the rocket. Until this point, that was their way off the pad if they needed to evacuate. But now with that arm retracting, the backup transitions to a launch abort system. And they'll begin arming that shortly. Of course, the launch abort system, great shot there of the crew access arm retracting away. The launch abort system is the tower at the top, and that's what would pull Orion and its crew off the top of the rocket in case of an emergency, whether it's on the ground or in flight. This is critical safety hardware that protects the lives of the astronauts. Starting at T-minus 6 minutes, the GLS will start bringing that and other high-energy systems online, starting with core stage pressurization. Weather is 90% go. The range is go. All systems are go.
GLS is go for core stage tank pressurization.
That means the replenish valve for the liquid hydrogen tank has now closed, and that tank is beginning to pressurize to flight levels because that hydrogen is naturally boiling inside the tank. We'll get the liquid oxygen tank a little later in the count. Now the team is waiting for verification that, if needed, the Artemis II crew could use the launch abort system to pull Orion safely off the top of the rocket in an emergency. Let's listen in for that call.
GLS verifies last capability available.
And CDR, do you copy?
CDR copies, last available.
That's great news, and you heard the NTD verify that with the commander of the mission.
GLS is go for FTS arm.
Now work is being done to arm the flight termination system. This is so the range safety can send a flight termination command if the rocket flies too far off track. There's a brief built-in delay, so the launch abort system has time to pull the astronauts to safety first.
GLS is go for LH2 high flow bleed check.
All right, the high flow bleed check. That's so the cryo team gets verification that the RS-25 engines, all 4 of them, are in the proper temperature range for launch.
GLS is go for core stage APU start.
Core stage APUs start. Those are auxiliary power units, high-speed turbines which provide pressure to hydraulic pumps that steer the RS-25 engines. We're going to see a gimbal test a little later at T-minus 2 minutes and 30 seconds. This is what allows that to happen. coming up in about 20 seconds. We're listening for go for purge sequence 4. That's a helium purge of the 4 core stage engines downstream of the propellant valve. This gets all the air and moisture out of there.
GLS is go for purge sequence 4.
Moving through the milestones. All is looking good. Coming up in just a few seconds, we're going to get that thrust vector control actuator test. This is a gimbaling of the engines. There are the 4 RS-25s, 3 of them Shuttle Heritage, 1 of them built from shuttle parts. And there you see them moving. Now we're going to start moving the power from both the upper stage and the lower stage of the rocket to internal, taking ground power away and now going to battery power.
GLS is go for upper stage to internal power.
All right, power is removed from the rocket's upper stage, the ICPS, and it's been switched to battery. Same milestone for the lower core stage coming up at T-minus 1 minute and 30 seconds. Right now, the 4-person Artemis II crew is 248,000 miles away from the moon. And if all goes well, they will fly by it in 6 days.
GLS is go for core stage to internal power.
All right, there's the rocket's core stage, which houses 3 flight computers, is now on its own power. There's no more hold time because there's no more margin on these batteries. So we would have to recycle back to T-minus 10 to recharge if we had a hold.
One minute.
Right now, the rocket does not know what the T0 is, but coming up at T-minus 33 seconds, control shifts from the ground launch sequencer to the rocket's onboard autonomous launch sequencer, or ALS. The rocket will count itself down, but honor any holds that could come from the ground. Now, shortly after liftoff, Houston will take control of the rocket, and my colleague Gary Jordan will take over commentary.
GLS is go for ALS.
Great call out. The rocket is on its own. 4 brave explorers ready to ride the most powerful rocket NASA has ever launched. Sound suppression water is flowing.
15.
And here we go. 10, 9, 8, 7. RS-25 engines lit. 4, 3, 2, 1. Booster ignition. And liftoff. The crew of Artemis II now bound for the moon. Humanity's next great voyage begins.
Good roll pitch.
Roger, roll pitch.
Houston now controlling the flight of integrity on the Artemis II mission around the moon.
Integrity, AMT high.
AMT high.
On time passing 30 seconds into the flights. Integrity passes the alternate MECO. Target milestone. Mission Control Houston seeing good performance on the 4 main engines. Space Launch System core stage. Integrity, 3 miles in altitude. Traveling more than 1,200 miles per hour. Mission elapsed time, passing 1 minute, approaching max Q.
On, Ponce de Leon.
Stan, we have you loud and clear on Ponce de Leon.
Have you the same?
Communication signal transfer confirmed as Integrity and its crew go supersonic. Approaching 90 seconds into the Artemis II mission. Integrity is 14 miles in altitude, 8 miles downrange, traveling more than 2,600 miles per hour. Minute 50 seconds of mission elapsed time, standing by for main engine throttle down to 85%, ahead of solid rocket booster separation, expected at the 2-minute 9-second mark. We see throttle down. Confirmed separation. Main engines throttling up, guidance converged.
Integrity, guidance converged, performance nominal, upper stage RCS ready.
Copy all, Stan.
Integrity, SM priming complete.
SM priming complete.
2 minutes 45 seconds of mission elapsed time into the Artemis II mission. Thrusters on Integrity and upper stage confirmed in a ready state, ahead of service module fairing separation. 3 minutes into the flight. Integrity, 49 miles in altitude, 78 miles downrange, now passing 5,000 miles per hour. Standing by for launch abort system jettison.
Houston Integrity, good last jettison, great view.
Copy jettison, Team Eco 8+02.
We see the same on board, Stan.
And Houston has you loud and clear on TDRS at the Kármán line.
Outstanding, Stan, we have you the same.
3 minutes 50 seconds into the flight of Artemis II, Wiseman, Glover, Cook, and Hansen cross the boundary to space with good comm checks. GPS signals acquired after last jettison now working on internal checks to verify accuracy. Flight Dynamics Officer analyzed the time of main engine cutoff, confirmed at 8 minutes 2 seconds, time of MECO.
Integrity, GPS processing.
Outstanding, Stan. We see the same, and we have a beautiful moonrise. We're headed right at it.
Approaching 5 minutes into the flight, Commander Reed Wiseman confirms he has visuals of his destination. GPS guidance, navigation, and control software finishes internal checks and sends to navigation channels.
Integrity, 3 engine press.
3 engine press.
On time, now passing 5 minutes 20 seconds of mission elapsed time into the Artemis II mission. At this point, 3 good main engines are all that's needed to carry Integrity to a nominal main engine cutoff target. Though at this time, we're seeing 4 good engines here in Mission Control Houston. Integrity, 75 miles in altitude, 330 miles downrange, approaching 10,000 miles per hour.
Integrity, looking good at 6 minutes.
Same on board, Stan.
Good trajectory and engine performance. Booster officer will soon report the shutdown plan to Flight Director Judd Friedling, expected at the 7-minute mark. Integrity, 78 miles in altitude, 460 miles downrange.
Integrity, expect nominal shutdown.
Integrity copies nominal shutdown.
Six minutes, 40 seconds of mission elapsed time. Shutdown plan is as expected. Again, the time of MECO was confirmed at 8 minutes, 2 seconds into the flight. Seven minutes of mission elapsed time. Throttling down as we approach the abort once around option. Milestone at the 7-minute 30-second mark. Now 84 miles in altitude, 650 miles downrange, traveling more than 15,000 miles per hour.
Integrity, AOA open.
AOA open.
The window is now open for an abort once around option that would target splashdown in the Pacific Ocean. Still following nominal ascent at this time. About 10 seconds remaining until the main engine cutoff of the Space Launch System core stage. Standing by for confirmation of MECO and core stage separation.
Integrity, nominal MECO, core stage separated.
We see the same on board, Stan.
Eight minutes, 40 seconds into the flight, we have a nominal main engine cutoff heading in the right trajectory on the way to swing around the moon. Core stage has separated, done its job. The Space Launch System upper stage, the Inner Rim Cryogenic Propulsion Stage, or ICPS, still attached to the Orion spacecraft. Nine minutes of mission elapsed time. Integrity crew of Reed Wiseman, Victor Glover, Christina Cook, and Jeremy Hansen now in orbit around the Earth at the beginning of their journey to the moon.
Integrity Houston, looking ahead to PRM numbers so far per the pad.
Copy that, Stan. Numbers for the pad.
Capcom Stan Loves now reminding the crew that the perigee raise maneuver time of ignition is as expected prior to booster ignition. That time being 49 minutes, 50 seconds of mission elapsed time.
Integrity, good. NEDs deploy.
Copy that, Stan. Good, NEDs.
And Integrity Houston for PWD setup. Just a reminder, halfway open on the secondary.
We copy that, Stan. Halfway open.
Passing 11 minutes of mission elapsed time. overhearing the conversation between Capcom Stan Love and Commander Reed Wiseman, already passing some milestones. We have a good nozzle extension deployment system. That is confirmed. Complete. We also have the visors are confirmed up, now past the dynamic phase of flight that is Ascent. Their launch and entry suits that provided them an extra layer of protection. Now not as needed. They're going to raise those visors. And later in today's mission, they will begin to egress or get out of the suits to begin some of their initial tasks of activating some of the systems aboard in the Integrity spacecraft. It's passing 12 minutes of mission elapsed time. Again, the perigee raise maneuver that's targeted near 50 minutes of mission elapsed time, 49 minutes, 50 seconds. That's what the crew is going to be working towards. The Commander Reed Wiseman, pilot Victor Glover will focus on preparing for that milestone. In the meantime, mission specialist Christina Cook and Jeremy Hansen will start some of the activation of environmental control life support systems. You may hear confirmation of their activation over the Orion to Earth communication network.
Houston, C3 aux power back in auto.
Copy, C3 aux, and we're 2 minutes to maneuver.
"13 minutes and 30 seconds of mission elapsed time. We're going to continue to follow the crew of the Artemis II mission. They are beginning their journey around the moon to verify the systems that will take us to its surface. An incredible ascent. Artemis II is underway. Reed Wiseman, Victor Glover, Christina Cook, and Jeremy Hansen begin their journey to the moon. Still milestones to come up as we await solar array deploy and the critical burns that will get Integrity into high Earth orbit around the Earth before engines are fired to get us around the moon. We'll keep tabs on Integrity and its crew from here in Mission Control Houston. But for now, we're going to send it back to you, Megan and Nicole at the Kennedy Space Center. Very jealous to hear how the launch experience was over on the Space Coast.
Yeah, Gary, for people who are just joining us, welcome back to the Space Coast, where we just saw Artemis II lift off 14 minutes ago. And wow, what an amazing launch, and an emotional one, too. As soon as the rocket lifted off, Nicole, you had tears in your eyes, I had tears in my eyes, and we had all these people around us cheering. It was amazing.
Yeah, the energy was wonderful. I mean, it was a beautiful launch. We've got 4 friends and family members headed to the moon. It's pretty amazing.
Yeah. How does that make you feel as someone who, is an astronaut as well, but also, as you said, friends?
Yeah, so proud of them. Man, we don't have the words in the English language to describe this kind of an event, and pride, love, so many emotions. They are truly breaking some barriers, and hopefully, as Gary just said, they've got a long day ahead of them, so wishing them well on everything, but so far, what a beautiful launch to watch.
Yeah, to be returning to the lunar orbit in more than 50 years. Maybe they go farther from Earth than any other humans before them. Maybe they see parts of the moon that we've never seen before. I mean, what a great start to what could be all of these milestones that we break in just a 10-day mission.
Yes, what a way to welcome in the Artemis generation.
Yeah, how do you feel? I mean, we saw some beautiful shots we were covering of course, the rocket, of course, the Earth falling away as we continued up into our ascents, but also some of those crowd shots where we saw young and old, just emotional, overcome by this history-making moment.
Man, we are going back to the moon for all, and we saw that today. We saw that in all the crowds. And you guys just saw that view, the sunrise or sunset, I guess. They just made it over the crest of the Earth, and you could see the sun peeking over. One of my favorite views from space, and I can't imagine what they're looking at now, and I can't wait to see what they're looking at in about 5 or 6 days.
Yeah, and I know a lot of people are like, I'm surprised this launched on the first try, because we know, like any little thing, we have to be keeping safety in mind, and we want to make sure we're ready to go. But we were ready to go, and I think it surprised a lot of people. What a wonderful surprise on this Wednesday evening.
It did, and it kind of surprised me as well. But, it's just a testament to the team here that has been working so hard on Artemis. Artemis 1, we learned a ton of lessons. We learned a ton from the wet dress for Artemis 2. We were able to go in, fix those things. We even had a couple mishaps today, not mishaps, but a couple, anomalies today that the team creatively came up with solutions for. It's just a testament to the teamwork that gets us to the moon.
And so we can continue to watch Christina, Reed, Victor, and Jeremy on their way now to the moon in Earth's orbit and awaiting the next in-flight milestones, deploying Orion's solar arrays. So why don't we get back in with Mission Control and Gary.
Hey, thank you, Megan. Again, we're following along in the action. It is a long day. They have a number of procedures they need to get to immediately in their timeline.
And Integrity Houston, crosstie is on board per the ETSIDEM.
We copy Houston. Thank you.
Crosstie referring to flight controllers here initiating a connection between some of the batteries aboard the Orion spacecraft, allowing for an even distribution of power. This is the flight control teams that took us through Ascent of the Artemis II mission today. Right now we're, as you see, passing 18 minutes of mission elapsed time. The Orion spacecraft integrity and the interim cryogenic propulsion system are maneuvering tail to sun. It is in this orientation, this attitude.
Integrity anywhere until that momentary prop caution.
And Reed, no action. We're looking at it.
Commander Reed Wiseman verifying what is being routed to his displays aboard Integrity. Propulsion engineer confirming that no action is needed at this time. They're pressing through with their nominal procedures to prepare for the perigee raise maneuver. And of course, the solar array wing deploy ahead of that. The solar wing deploy is a critical milestone. We'll continue to have our coverage follow the mission until that deployment. Successful launch is just the beginning. The deployment of the solar arrays and successful confirmation that those solar array wings are drawing power is a significant milestone and says to the flight control teams that we will continue on today's mission. Power needs to be drawn to continue through some of the next milestones. Until then, the AOA open option that was called up upon ascent, the aboard once around, is the current option, and aboard to orbit option ATO will be switched to a preferred mode at the time that the solar array wings are deployed and latched. It gives the flight control teams a little bit more flexibility.
Yeah, Integrity Houston, update on TDRS handover for your pad.
Give us just 1 minute. And Stan, you can read it. Ike is ready to copy.
Roger. TDRS handover east to west expected 1 second earlier at 5:1 minutes 26 seconds.
Hi, Stan. We copy 1 second earlier for 5126 TDRS east to west, and saws are starting to deploy. Thermal knives are firing.
We concur. Thanks for the report.
Read back of the reports that you just heard on the Orion to Earth network. Integrity has maneuvered tail to sun. The RL-10 nozzle on the end of the ICPS is pointed towards the sun, and the solar array deployment sequence has begun. With the deployment confirmed, it'll be several minutes until they are what is called in a latched position. Once they are latched and confirmed to be drawing power, they can switch the mode to ATO and continue along the mission. The teacher's handover at the pad, that message meant the crew was provided some preliminary numbers of when to expect handovers between the tracking and data relay satellites. Currently orbiting Earth at an altitude of 545 statute miles above the Earth, they are in a near-Earth network communication system. The tracking and data relay satellites, geosynchronous satellites that are stationed about 23,000 miles above the Earth. After the apogee rays burn, that occurs later today, the burn itself will put them in an altitude that surpasses the range of the tracking and data relay satellites, and they will transition to the deep space network today.
And integrity for prop messages, we see 2 temperature measurements right near the line. It's that momentary message you saw earlier. We're going to suppress those. It's CM helium heater 2 T1 and heater 1 T1. They're going suppressed.
Integrity, thank you. We see the same.
This is Mission Control Houston, passing 23 minutes of mission elapsed time into the Artemis II mission. This is after a launch that began at 5:35 and 12 seconds Central Time, 6:35 and 12 seconds p.m. Eastern Time. Right now, the orientation you're seeing from our arrow visualization that translates some of the telemetry that we're getting from the spacecraft and puts it into a model so you can follow along on some of the milestones that we are following here. The RL-10 nozzle that you see at the left end of your screen, though it is currently not firing, that nozzle is pointed towards the sun, and the solar arrays are currently deploying. From this visualization, they looked fully stowed in a position.
Integrity, we are happy to report that Jeremy has the O2 sensors on.
Copy O2 sensors.
Again, Commander Reed Wiseman and pilot Victor Glover overseeing the deployment of the solar arrays. And we'll follow the attitude maneuver changes ahead of the first burn of the ICPS engine, the perigee raise maneuver.
Integrity Houston, we see 4 saws deployed and latched, ready for ATO preferred.
Yeah, we're almost there in the procedure stand, and we see the same thing.
And Integrity Houston, we are seeing a 7-second miscompare between the MET on a